I'm doing this is I'm actually a big student of this field, to be honest. I mean, this is called a masterclass, but I'm actually a student of this field. I try and learn something about this every day. I follow a lot of influencers in this place. It's a passion that I picked up about 5 years back. I mean, I've been in data all through my life, but visualization is something that I picked up the last 5 years, and I'm building a product on visualization in the space of customer experience, CRM, and all of that stuff. But this is a field that is very close to my heart, very passionate. I'm more of a student than a master. And what I'm hoping to here is maybe rub off some of the enthusiasm on you guys and get you inspired to do something on this, if not as a full-time job, but at least as a skill that you really like, right? So that's the agenda, the reason why I'm here today, first of all. So these are the topics that we're going to go through. We'll set up a preamble in the beginning, set some foundations right, and I'll give you an intro to what is database, set some definitions, give you some historical context. How did it evolve? Where is it currently? Where is it going? Some of the design aspects in terms of how do you do visual design around visualization, the different charts. We'll try and create some visualizations ourselves. We'll talk about the different techniques and how you tell a story using data. This is a concept that's been very prominent in the last few years, but even more so now, because people's time and attention are limited, and if you want people to remember what you've explained, storytelling is the way to go, right? If you want to create that moment in their minds, you want to be able to convince, whether it is your executives, your customers. You just don't take a pretty dashboard with 20 different graphs and say, okay, now go make sense out of it, but you actually walk them through what is the story behind the data that you're presenting. And last but not least, more important is we'll go through all the different tools and resources that are there, so that after this class or after this session, if you want to build more stuff, you want to acquire more skills, you want to learn more about this, these are the links for you to go from, right? So this is the way in which we break down. We'll take questions in between. Feel free to stop at any point in time. This is interactive. It's a Saturday morning. So look at this. If you don't ask a question, you'll forever probably not know the answer to it. So think of it that way. And that's the way I motivate myself sometimes to ask a question, right? So just to kind of break the ice and things like that. So feel free to post questions in between. We will have polls running in between just to keep things interactive, and we go from there. Okay. All right. So let's get started. Now, the first thing I want to set is, before we get into visualizations and all of that, I think we need to set the foundations in terms of going to the root of the tree and starting from there, right? The question that you got to ask yourself today, especially in today's world, is, do you speak data? In the sense that, are you able to use data almost like a language, right? When you, like, for example, in your business environment, you're talking to your customers, your management, you're talking about your customers, you're talking about your products, you're talking about process. A lot of English gets used, a lot of opinions gets expressed. A lot of it, some of it may be objective, some of it might be subjective, but then the world is moving towards a place where data is almost becoming a language of expression, a language of communication. And what that enables is, it makes a lot of things objective. It removes all the subjective elements, because data is fact. And then so when you talk using data, you are expressing facts. And so the credibility builds, people understand what you're talking about, and also expresses, details about that you do know what you're talking about, right? So let me give you an example. So in all your business, the companies that you work for, right? Take a couple of minutes and say, if I were to describe my customer using data as a language, how would I describe it? Let's say you're talking to your colleague, you have a set of customers, let's say, who have run into problems. You see a spike in, support tickets coming up, or you see a spike in churn that is happening, or you think you need to be doing something else for this customer. We need to maybe able to develop this new feature for this customer. It kind of goes to the question, like, how would you define your customer using data, right? I mean, generally people say they're a company, they're an MNC, they're an organization in hardware, they're an organization in manufacturing. But those are very sort of abstract terms, especially given the fact that we're talking about visualization. If you're going to express your customer using visualization, you have to be able to describe the customer using data, right? And what I'm trying to get to is something like this. Like, before we get into the way you express customers using visualizations, which is a form of communication, you have to be able to kind of go back to the source and understand, how is the data for this customer defined? What are the attributes of this customer? What are the sources where these attributes are managed? What are the type of values that it can have? What is the relationship between different, let's say, dimensions of a customer? And can I then use this to define who my customer is, right? So for example, I have, so who's your customer type? So is it an organization? Is it an individual? Is it a household? Is it a contact? Is it a public company, private company? What is their firmographics? What industry do they operate? What is their profit line, revenue line? What is some of their master attributes? How do you define this customer? Are all customers whom I sell to? Are there certain customers who I don't sell anything to? What are those types? What is the hierarchy in which they operate? What relationships do we have between different customers that we have within our business, right? What is the relationship that we have that, for example, a certain customer has with the product? Which products sell well? Which customers are in which region? The point being that when you're talking about describing a customer using data, the language and the grammar that you use to describe your customer are these different dimensions and attributes. And when you're getting into this field of visualization, it's very easy to pull up a pie chart or a bar chart where you take, for example, a customer name, and then you want to plot sales by quarter. It is very, very easy. But then if you don't understand how was that customer defined in the first place, how are they onboarded, how is the data defined, what is the type of customer, what are the different types that are possible, and if a customer is new, what is new, right? Is it new for this month, this quarter, this year, last year? What is it, right? That level of data understanding is required. It is mandatory before you even start expressing those customers using language, right? And this kind of goes down to this notion of what Gartner, for example, last year talked about this. It's a very nice read. I have the source in the bottom here. They talked about information as a second language. So data is pervasively being used in businesses today as a business language. But unfortunately, the problem is that not everybody speaks this language, right? So you should think of any communication that you have with somebody from the other department, like you talking to somebody from support, you talking to somebody from sales, you're talking to somebody from marketing. They all don't speak the same language. And I said they all don't speak the same language, I mean in the context of using the right grammar, in the right context, and the right definitions. So if you were to ask the previous question, who is my customer, or describe the customer, you will guarantee to get a different definition from sales, from service, from finance, from your engineering, from product management, different folks, right? And that is fine because each person has their own view of what the customer is. But then if you're going to get into this data business and then use visualization as a way to express or describe who your customers are and what is possible, right? You need to be able to have this understanding of what are the different attributes and dimensions that are related to a customer and how are they defined and how can I use them? Because if you were to ask questions on the data, for example, you had, let's say there was a spike in the number of support tickets on a specific set of customers last month, you have to be able to answer the question, okay, what do I want on the data for me to understand why this is happening? So for that, you need to know what are the different types of service tickets, what are the different type of products, what are the different types of assets, how is it defined, is there a specific region, all of that stuff, right? And all of this kind of goes out into this concept of what we call data literacy. This is the ability for people to read, write, and communicate using data. And this is increasingly becoming more and more dominant. Data used to be a niche domain that only data folks used to do, but this is now almost a horizontal feature that everybody now needs to be able to read, write, and communicate data. And think of the time when you've seen a pretty dashboard. Did you really understand what was written up there, right? Were you able to make sense of what is being communicated in the dashboard? Maybe you have been, but not everybody does. Sometimes people just look at a pretty dashboard and say, oh, this is great, but the ability to understand what is written is not something which is very common. It's actually a barrier. And Gartner says that this is the biggest internal roadblock, right? In fact, they say this is the second internal roadblock to any success within organizations. On the Q&A, just type in what do you think is probably the number one roadblock for any initiatives within an organization? And I'm just trying to get you guys involved. Put your answer in the Q&A. So if data literacy is the second biggest internal roadblock to success of projects and initiatives within the organization, what do you think is the number one roadblock that probably was there? Access, Pratul says access to clean data. Okay, that's not bad. Anyone else? Think broad. I mean, you don't even have to go to that level of data just because you think of the last time you had a conversation with somebody within your organization and you had to get something done. What was blocking that conversation? Overloading of resources. Okay, Vijay says overloading of resources. Fine. What else? You'll actually be surprised. Actually, you won't be surprised. And when I give you the answer, Jaideep says understanding of different data. Yes, that is also true. Not everybody understands different data. Sales guy will probably not understand. You say I have a party ID, right? I have a party of type account, and you probably go, what is going to happen? Sonia says extraction of data is a problem. Yeah, that is true. It's not easy for people to do self-service, right? I mean, the moment business gives their operations team, IT team, a report to go build, it takes weeks for them to build. And half the time is spent on extracting data from the sources. They don't even know where the sources are. And they have to go figure out what is going on. That is also a problem. But when I give you the answer, you'll all be like, oh yeah, true. That is the biggest problem. And I'm sure all of you will resonate. Satyak says lack of faith and confidence. Yeah, trust in data. When I see a dashboard, do I trust the numbers? What actually Gartner said was the biggest internal roadblock to success. And when I say the answer, you all be like, oh yeah, that is true. This is actually culture. The culture within the organization, in most organizations, is the biggest roadblock for success, because change initiatives, getting people to agree, people to look at the bigger picture, looking at the better good of what is happening, that in fact is the biggest roadblock to any kind of initiative that organizations try to run with the disruptive times that we are in. And that's actually slows down a lot of the project. Then after that comes the ability to use data to make decisions, the ability to read, write data, the ability to extract value out of data. And number three, actually, the reason in that report was around skills. I think you guys talked about some of that a little bit. I mean, if I give you the data, let's say there is a salesperson, I give the person a data, does a guy really have the ability to create self-service analytics? So data is getting increasingly used as a business language, and you have to be able to use this as a meter within your organization, whether it is your sales folks, your interdepartmental communications, your management. Try and look at separate conversations between subjective and objective ways of communicating. When people communicate objectively, they use a lot of data in their arguments. And that reflects their ability of how they have understood how data is created in the organization. And that is foundational for anything you do on top. If you don't understand how your customers are onboarded, how data is created, who manages it, who governs it, how are the different entities associated to it, what is the grain in which something is analyzed, what is the cardinality between a customer and a product and an account, product and a support ticket, you really will not be able to put together meaningful visualizations. It will all be pretty, but it will not be meaningful. And this data literacy as a component itself is it has multiple aspects to it, right? This is a very nice visual that I picked up from ResearchGate. When it talks about when you say data literacy, again, we talked about data literacy is the way for you to the ability for somebody to read, write, just like English literacy or numerical literacy, is your ability to read, write, and communicate data. But then this competency itself has multiple aspects to it, right? So starting from, for example, how is data collected? A lot of the times you see surveys and facts being quoted. 80% of our customers said that they want this. The question is, okay, who are these customers? What was the question? What was the sample set? How were the customers in that sample set picked up? How do we know that there is no bias there? Are these all happy customers? They are existing customers. They are prospects. They are customers who left us. It all starts with an understanding of how is data collected. right? How is data collected at the source and what do you do with it? Once you have that understanding, again, that's why it's so important that every time you read a survey, anything like that, you go back to the source and understand what is that source, how was that collected, right? Then from there comes the understanding of, actually it starts with the conceptual framework of understanding data itself, like what is the element. So if I have a particular data entry or a metric or an attribute, what does that mean? If I have an organization customer type as an attribute, what does that customer type mean? It starts from there. From there you go and collect the data that is relevant for it, and then you start managing it, right? So have your data entries, your source transactional stuff, different users come in, there are workflows, there is enrichment, there's data quality, all of that stuff. And then comes data applications. Think of these as reporting tools, for example, applications that help you manage the data, and then you analyze the data in the end of it, right? So there are different skills that are relevant, that is needed for somebody to understand what data literacy means. I'll give you an example. I'll come to this in a second. I'll give you an example. So think of this as, so the question is, how do you read this weather forecast? We all read weather forecast, right? There are different data points that are expressed in a weather forecast. Weather forecast is an interesting data point in that it is not a single number, especially things like rain, right? It's not a single data point. It's a combination of multiple data points that you have to look at it in big picture to understand what is happening, right? Now, what do you see here? So you see temperature, and then it says a few showers, and it says chance of any rain is 60%. And there's possible rainfall that is 2 to 10 mm, right? Now the question is, how do you read this? So if there's a question, maybe Suraj, you can launch this poll and let people answer. Which of the following is true? If you get to pick one. So let's say you're deciding, should I take an umbrella or not, right? So the question is it true that 60% of chance in a rain between 2 mm and 10 mm? Is that what it is saying? Or is it saying 60% of chance of rain in a 24-hour period? Or is it saying that because 60% is going to be 2 mm, which means 60% is 2 mm, which means 40% should be less than 2 mm, right? Okay, it's this again, feel free to whatever go through this concept of rational thinking and then pick up what you think is right. I mean, it's okay. We most of us probably don't get this right the first time. 5 more seconds. Excellent. Okay, that's good. In fact, most of you got this right. The correct answer is that there is a 60% of chance of rain in a 24 period. Now, we could have this discussion of why isn't the first one wrong, right? But the question is, when you, again, thinking about data literacy, you got to think about what do these numbers mean? How were they captured in the first place? Like when he says chance of any rain is 60%, what does any rain mean? Is there any correlation between this and this, right? Are you making one? Are you making a correlation that when it says 60% rain, that means 2 to 10 mm? Are you making a implicit assumption that 2 to 10 mm is the range, as in this is minimum and this is maximum? I mean, you can't say possible rainfall and then guarantee 2 mm as minimum, right? Now, the way to read this is, again, it goes back to the whole concept of how is data collected, how is data measured, managed, all of that. This 60% is actually, when it says any rain, the minimum amount of rainfall that you can calculate or measure is actually 0.2 mm. So when it says 60% of rain, what it says is there's a 60% of chance of rain. Again, if you go down this path, you got to think about how is chance measured, right? So what is chance? Chance is probability of rain happening in that area of that place. So if you say if there's a 50% of chance of rain in 100% of area, then there is, 50% of, there's a 50% probability that 100% of that area will rain, then the chance of rain is 50%, right? So in the same way, the 60% is actually, when it says any rain, you have to understand, got to go back and say, what does any rain mean? It's not 2 mm. You should not incorrectly correlate this with this. 60% of chance of rain means What is the minimum that I can calculate? And that is actually 0.2 mm. Then comes, what is this, right? So looks like there are extremes of a range. And the way these numbers are expressed is by the weather forecast. And this is actually a pretty standard model across. Is that anytime when somebody says possible rainfall, precipitation is being displayed, and then you're using a number. The first number actually means this is 50% of chance of this occurring and 25% chance of this occurring. Right? And so there's no 60% and these are not, there's no correlation between these two. When we say 60%, it means actually minimum of 0.2 and then 50% of at 2 mm and 25% at 10 mm. This is fairly, it's going to be, I think the answer is, I would definitely carry Numberla, right? Because it looks like, I mean, it's a 60% at 0.2 mm, and it's saying there's at least 50% of chance that it will be a 2 mm range. So I don't want to get drenched. So maybe I should carry a Numberla. Now, the question is, you might say that, look, I don't know that this is the format and model in which weather forecast numbers are expressed. And that is fine. But the point is that if this was not weather forecast numbers, but these were actually your reporting numbers within your organizations in which certain measures and outcomes are being presented, and somebody says chance of customer churn is 60%, and somebody were to say plot a visual for this and tell me what is the churn rate for the last 6 months, you have to be able to go back and understand how is churn rate first of all calculated, right? What is the formula for it? And if there is any other range, if there is any certain predictions, there is any other forecast that is being done on your data numbers, you got to be able to understand how is the data collected, how is the data measured, how is the data represented, and how should I as a user read it before I even go and make any visualization on top, right? And this is the concept that we were talking about here, that data literacy itself is one of the 6 different literacies that we are all supposed to have. And again, this kind of goes back to the point that data visualization is not a simple thing, that it's not just taking a bunch of numbers and putting a pretty graph on top. You have to have different literacy components to be able to make a meaningful presentation of what is it that you're talking about, because there can be questions, there can be reasoning, there can be digging deeper, and you got to be able to back up what you're presenting. So there are different literacy levels, right? So it starts with, for example, let me start with the top. So it starts with information literacy. Information literacy is about taking your data and then creating information out of it, right? So probability on something is information. If you aggregate, if you do summarizations, you calculate totals. If you are using, for example, 60% of my customers of type small and medium business are likely to churn, that is information. So taking data, and people who are fascinated in this space can go up and read this concept of DIKW. And probably most of you know this. How do you progress data from the core, raw form that exists within tables? How do you move it up to information where you're making meaning out of this data? How do you take a collection of information and make it, collection of information sources and make it knowledge that you can go back and refer? Google, for example, right? A great example for knowledge. And then wisdom. Now, wisdom is you apply human ethics, you apply judgments, you apply wrong and right or wrong, and good or bad. And should I do this? Should I not do this? Sort of judgment, right? Stuff which is very human, and that is why wisdom is a human characteristic and not a machine characteristic. So you need to have information literacy. When you take these raw numbers and you have information created out of it, you have new metrics created up, you should be able to understand what does that mean, right? Next level of literacy is statistical literacy. Statistical literacy, again, calculating averages, deviations, means, correlations, coefficients, all of that stuff, right? So when somebody presents a graph and says that the correlation between these two values is 0.75, you got to be able to understand what does 0.75 from a correlation factor mean. So that statistical literacy is also important before you start expressing it in a visualization. Critical reasoning is extremely important. So when you have data in front of you, it all starts with what questions are you asking on the data? Going back to that weather forecast, what is the question that you're asking, right? The question that you're asking is it going to rain today? And if it rains today, how much? Right? And so anytime you're doing any data investigation, data exploration, whether you're from a data science background or otherwise, you have data in front of you. You've got to be able to ask the right questions and go down the path of how do you investigate, analyze, and make sense out of it. So that critical reasoning is also important. Then comes technology literacy. Given all of this data, can you then create meaning out of it? Can you create reports out of it? Can you extract meanings, insights? Can you discover patterns? Can you think of this as your PowerPoint presentation, right? So can you use tools to take this data out and present it. And last but not least, visual literacy. Visual literacy gives understanding of what does a particular color or a shape mean. Can I, for example, use for a certain type of data that I have, can I use a particular graph, right? If I were to compare two numbers, what should I use? If I were to plot something over a period of time, what graph should I use? How can I represent a third dimension in a 2D graph? How do I show composition? How do I show relationship? Visual literacy deals with the visual grammar of which shape do you use, how do you put colors and other visual attributes, where you're taking the encoding from your raw data into a visual form. Again, you can look at this yourself, and I've been in this shoe myself. I mean, I've been in this data for a little bit of time, but when somebody paints a really nice, beautiful dashboard with, again, like I said, 10, 12, 15 different charts, and people go, wow, it's beautiful, I guarantee that half of them actually don't understand what is being presented. Like, they don't understand how to understand what is a particular chart saying, what question should I ask in it, what insight is it giving me. So this visual literacy is also a literacy level that not many people have, and it's a problem that the people have to kind of gauge, right? And we looked at it in this example. And before we get the actual data, I just want to show you this. This is the actual picture. When you look at data visualization, it looks like a iceberg effect. What you see on top is a pretty nice picture. But that pretty nice picture needs to be built on top of a lot of solid competencies, starting with your data literacy, understanding the ability to where did the data come from, how is it related with something else, what is the cardinality, how are the different objects related, what are the different types, what can I do with it, right? And then comes your critical, and then comes the information literacy. What can I derive from this raw data? How can I make sense out of it? Can I use statistics to give characteristics of what is happening with the data? What questions should I ask on data? And this is so difficult. If I give you a data set and say, think about, let's say HR gives you a data set and asks you to figure out some analysis. It's very difficult for you to even ask a question. Okay, what question am I asking on this data, right? And that is such that it is important. And this comes with practice over a period of time. Then comes technology literacy, the ability to use visualization tools to be able to take all of this data and make sense out of it and be able to express it. Think of PowerPoint presentations. It's the same way. Can I use a tool given a data set? Can I do something on top? And then visual literacy, how do you bring all of this together? So just like English grammar, English language, you know all the different words, and you know how to use it when to express it in verbal form. If you were to know all the different charts and different visual elements, do you know how to construct that to be able to express data in a visual form, right? And before you start building stuff on, this is easy. Believe me, this is easy. In fact, tools will do a lot of the work for you. But what is hard is this. And this is where bulk of the time is spent for you to be able to create a meaningful visualization expression of what is actually happening. Okay. So let me just pause here before we get to the next slide. And I just want to open up for Q&A. If there's any questions, feel free to post on the Q&A, and we just quickly address some of those, and then we go from there. Any questions? Pratul asks, is a need for corporate standards and data standards as well as visualization a must-have in the first step? That is actually true, Pratul. In fact, there are, again, the driving factor that I've seen in customer organizations is the culture and the emergence of the CDO, right? The Chief Data Officer in different places. In fact, I know organizations where the executives are compensated or penalized based on how good or bad their data quality is. And so they have measures and KPIs to look at how much nulls do they have, how much of junk data do they have, because until and unless they make these executives responsible for data standards, ethics, privacy, compliance regulations, all of that stuff, the rest of the organization doesn't really rally around. And what I have seen is it really depends on the culture of the leadership. And if they have people like CDOs and they have measurements in place to understand, are we treating data as a strategic asset, and is this being communicated properly everywhere and things like that, then it is done. In fact, there are a lot of companies doing training now on data literacy to their employees. I mean, think of a sales guy. You give him a dashboard. Do you really think he understands how to read a scatter plot or a network diagram? They don't. So they're trying to express all of that to these guys from there. Kumaran asks, how do we communicate customers, users with these complexities? Yeah, so the way that it worked for me, it's not an easy way. Let me be honest. It's not easy. It's a big change cycle. It doesn't come. We humans are, by nature resistive to change. One technique that I've used that works for me is I show how it will impact them and the work that they do. I'll give you an example. There's a line of business executive who is if I'm trying to sell this to a management executive, and let's say he has a P&L account responsibility for his business unit, and obviously he's going to he will report data upwards, and he will, he has to show how his numbers are doing because he's responsible for that. And before I get into any of these exercises, one thing that I do is I show them how poor the data quality is. And I show them how you cannot make decisions on the data that you're currently reporting because 20% of your data is junk, or there's no proper governance on how you're trying to manage all of this. Or we take a look at, for example, their visual literacy components and say, look at all your dashboards. I mean, we show them how they're not being effective for their users to understand what is happening. Look at the time taken for a report to be created. How long, again, going back to technology literacy, really, how long does it take for somebody to create a report? So in short, what we do is we look at ways in which we try and we show the problem to the user in a way where they're able to see this as a problem for themselves. And it will affect them and their job that they do. Unless you do that, it doesn't happen. And then you can't actually do it at a user level. So what we do is we go at the management level for each of these users, and we try and highlight the cost of doing nothing. If you didn't do this, what would be your problem, right? And that will not necessarily mean they will change everything, but it'll get them thinking. It'll get them, worried that if I don't meet this, my job is at stake and things like that. And so they start getting proactive, and then they start learning. We sit with them, we educate them, we make things easy from a product perspective, and we go from there. So that's what we do. One way to do, but then it's not easy at all. No problem. Rajesh asks, how should we go about enhancing our understanding of foundational competencies for database? Any good books, resources that you can recommend? Yes, Rajesh, I do have a section towards the end of this presentation where I talk about different resources, people. So one quick way to do this is to follow some thought leaders in this space. There are several thought leaders in this space, and they have their own YouTube channels, they have their own blogs, they have their own websites, they do talks and all of that, and you just kind of listen to them and sort of get inspired. Then you slowly start building competency from it. That is one way. And another way is to actually try it. A lot of the times we look at visualization, say this is easy, but then unless you actually try, you wouldn't know how to do this. So in to crisp up the answer, it's set yourself this roadmap of how you're going to build those skills. Start with, for example, one of the literacy components. If you were to say, let's say I want to pick up the visual literacy components, follow some of the data visualization thought leaders in the space and see what they're doing, the work that they're doing, how are things evolving, and things like that. And then start applying that within your business context. So take your data and then start applying those concepts in there, and then you slowly build up from there. You go from there. Okay, all right. So let's move on to the next part, which is the actual introduction of visualization. Now, there are lots of introduction to visualizations, but the one that I like to share is something like this, right? So I'm just gonna share my spreadsheet for a second. Just bear with me. Okay, so okay, so I've got I'll explain in two forms, right? So suppose you had some data like this. I'm just going to enlarge this so that you guys can see. So you had year, and then you had let's say product category, and then you had, let's say, sales. I'd probably add a month. So let's say this is 2020 and this is Jan, Feb. I'm trying to give you a definition that you probably won't find in any other literatures. So, and let's say I have three different categories. Let's say I have electronics, I have apparel. What else? I have, let's say, furniture. Right? I'm just going to repeat this for the others. Right? So I have data at a grain level, at a time grain level, at a month grain level, and I have different product categories, and then I have some sales. So I'm just going to pick up a random between 1, comma, I don't know, let's say 5 numbers. Yeah? So if the question was, let's say the question was this, right? I'm just going to comment this. Which are the top 3 months for each of the product category in sales for each of the product category in 2020? Okay, so let's say this was the question and you had this data, right? What will typically happen is you will start doing some kind of sort in your mind, right? So you'll probably look at the first number. Okay, I'm looking at 9 here, maybe 9. So apparel, 9, May is the highest. Then I go to, I don't know, furniture, and then I look at each of those and I see, okay, there's 8 here. There's also 8 here. Then you look at the second number. So you're looking at some kind of sorting in your mind to answer this question of in which month did each of the top categories did well, right? Now, instead, if I were to do this, right? So let's say I pick these, I say insert, and I say chart, and I say column chart. Your answer is now a little faster, right? So apparel, for example, shows up right. I mean, it kind of pops in front of you, right? I mean, this is the highest, for example. Apparel did highest in the month of May, and then furniture did really well in the month of September, and then electronics did well in the month of July. So it probably took you like 5 seconds. Now, if I keep changing these values, again, your sort is going to be, mental processing is going to be different. So what is actually happening is this is the way to understand this, right? There's a shift in processing that is happening in your brain, which is shifting from cognitive processing to visual processing. This is it from here. I'm using a Mac. Okay, all right. So the way you're processing this and the way you're processing, what is actually happening is there is a shift in processing that happens in your mind that is automatic and subconscious. It's not even something that you can try. Think of your brain having 2 different processors, right? The one processor is using this, and then there's another process that is happening that is using this. When you're looking at this data, there's a shift in that process in your brain that is automatic. I mean, you don't even have control of it, and that is actually fast. That is actually subconscious, and that is a lot more better tuned for you to understand what is happening than numbers and text. Right? So that's one of the foundations for what is data visualization. In that, data visualizations create the shift in processing in your minds, which is an automatic switch. And that second processor that it is using, which is visual processing, is actually faster. It is subconscious. It is tuned for super fast responses. And that's one of the reasons why you're able to understand this a lot more than, for example, this, right? So anytime this can keep changing, but your responses on this side will always be faster compared to this side. That is one way. Another thing is, if, for example, let's say you had, I have this concept of this is, so there was this French mathematician, actually English mathematician by name Francis Anscombe. He was a statistician, and one of the things that he came up with was this concept of Anscombe quartet. Some of the people from data science background would probably know this. He was having an argument with some of the statisticians that, they were saying that, look, numbers are facts. They are reflective closer to what it is, and graphs are approximations. They're not the real truth, right? And so he was trying to make a point that, look, you can have numbers that are very similar to each other, but then they have a completely different characteristic to each, right? So I've kind of taken his data set, and he actually calls it XY, and I've changed that to cost and price. So let's say, assume you have 4 products, right? So A, B, C, D, and then you have a cost column and you have a price column. And if you wanted to know what is the correlation efficient between cost and price for each of these products, so what you would do is you would use the correl function and say, correlate this data with this data. And I can round this off. Actually, it looks like I missed a column. So B16, B16. So I will round this off to 2 digits. So you have 0.82. And I can calculate this for all of the others. So I don't need for this, I don't need for this, I don't need for this, and I don't need for this. Now you see that the correlation value is the same for each one of these products, but although the numbers, especially for the price, you see here, they're all very different, right? So anytime you have a correlation factor which is greater than 0.7, it means there is a strong positive linear correlation between those two values, right? And then you can also calculate some of the other statistical measures. For example, let's say I calculate average of values, right? If I were to calculate the average of values for this is 9. And I can calculate the values for all the others, and you see that it is consistent. This is 7.5, this is 9, this is 9. But then when you plot a graph, right? So let's say I take this and I were to plot, move this zoom thing away. Oops. Here is the data format. So let's say I insert a chart and I see a scatter. So you get a scatter like this for the first one. And same way if you do this for the others. See, there is a completely different distribution between the first set and the second set, right? But then their correlations are the same. And likewise, if you plot these for these, you'll again see different values. This is for the third set, then I'll pick the last one. You see what I'm talking about? If you use statistical measures to describe this data, you will find that some of the values might be the same, but then when you plot them in a graph, you see completely different things, right? So for example, here, if you were to plot a trend line, you see a positive linear relationship, right? Everything, there's a causation. As X increases, Y also increases. Now here, if you were to do the same, you see that it is not uniformly distributed, but there is some sort of prediction about how this is more exponential than DMA, right? And you see this one, I do the same thing. I add a trend line. You see there is an outlier here. Now this outlier, the value is actually much lower. I mean, this is actually not 0.82, it is actually much higher, but this outlier has actually brought that value down, right? And so there's an outlier in this data which is causing the value to be 0.81. Likewise for this as well. And this has got a different, completely different relationship, right? So the point again of visualization is that this is one of the reasons why the principle is you always visualize before you start doing your summary statistics or start doing your modeling and all of that. The idea is to do exploratory analytics first, just to visually plot the data and see, are you looking at any visual patterns? One of the reasons why we do pair plots and exploratory analytics, right? And so just want to kind of set these two things down before we go into the actual definitions, that with the Anscombe quartet, that when you saw this, the first one that we looked at, right? When you look at visualization on a particular data, there's a shift in processing that is happening within your brain, which is automatic subconscious. And that shift is from cognitive processing to visual processing. And this visual processing is much more optimized. It is faster. It is quicker. It is easier. This is cognitive overload, and this is not. And in the field of communication, when you're communicating something to your management, to your customers, to your team members, and you want them to get what you're saying, even if with English vocabulary, we don't look to use complex words, right? We want to explain them in simple terms. And you will see this within our own working environments. The ability to express something in very simple terms is actually the hardest thing to do. People may know a lot of things, but then you ask them to explain it in a way that a 5-year-old can understand. It's very, very hard. And that's the same thing that is happening here. It is very easy to explain this, but it is very, very difficult to explain this. And that's one of the fundamental philosophies, principles that visualization solves. It creates a shift in processing from your cognitive to your visual. And the second one is this thing that we just looked at, which is Anscombe, right? Where is that? This one. That you could have data that looks very similar, but then unless you visually plot them, there are chances that they're actually not all that similar. And so the way you ask your questions and you go forward will be very different. And that's one of the reasons why you always start with exploration of your data first, understand how it visually looks like, and then go down to a lot more deeper, either creating of summary statistics, or you want to create any predictive models on top, or you want to create any derived metrics on that data, comes a little after that. Right? So that's sort of the context. Okay. All right. So let me go back to my presentation. I'm just going to share my screen again. Thanks, Sherna, for that tip. Okay. So that's one of the reasons why we talk about visualization. So for me, visualization is applying data in a meaningful context and applying the right presentation science. Is in the right format is data visualization. And like we saw in the earlier case, it taps into this visual processing that we are all born with. And there is a lot of research that happened in the last 20 years as to how our visual processing is actually a superpower that we have, right? And they actually translated that into numbers. There is research that shows that we can process visuals 60,000 times faster than text. In fact, 90% of the information that you see during the day is visual. What you process is coming from your senses, right? So your sight, your smell, hearing, your primary senses are your input sources. And in that, sight is actually 90%. And then think of all the evolutions of billions of years of evolution that we've had. We can actually process something very, very quickly. In fact, they say that you can process something in a tenth of a second. That is how quick your brain can process something and understand what is what, right? And let me actually show you. So I'm going to run an so we'll try and prove this, right? So that the brain can get a sense of a visual score in less than 10 seconds. In the next slide, I'll show a series of changing images. What I want you guys to do in the chat or in the Q&A is tell me how many images you saw, right? so that we get a sense of how quickly we're able to process. So you will see a series of rapidly changing images 2 times. And I just want you to type in what image did you see. Okay, you ready? All right, where we start. Okay, this is an obvious clue. I'll go back and come again so that you can look at this again. Can you guys type in your chat or Q&A, what images did you see? There's a poll. Thanks, Suraj. So those are the images. What did you see? Which of those images did you see? Great. I think we can stop the poll because people will have a hard time remembering. Actually, the answer is all of the above, which 4 of you got. But you get the sense, right? You were able to not just identify what the image was, but you were also able to kind of identify what that object was, right? And that is not easy. And that's what we're talking about in terms of how effective are visual senses. Again, how does this matter in the concept of the field that we're talking about? Is again, you look at people's attention span, people's time and patience to get into details. And you're doing a presentation to somebody, you're doing an elevator pitch, you're trying to communicate something to somebody and get them to agree to what you're saying, right? How quickly can you communicate that and how quickly can they get will have a huge factor in terms of their understanding what you're being communicating, right? And so that is why there is always a saying that don't use a lot of text in slides, use a lot of numbers, keep things low and all of that. Let me just see if there's any question. Okay, those are the answers. Thanks, Asit. Good to see you, by the way. Okay, and there was actually a Dutch scientist who actually measured the bandwidth of our senses to something that is comparable. And he actually said that our sense of sight is more than a Gbps speed, which is the same as our computer network balance. So in a second, you can process about a GB of data. And these are some of the driving factors why visualization is picking up so much of importance in the last, say, 5 to 10 years. I mean, it's been historically been very important in the last 20 years, but then especially the last 5-10 years, it's been picking up a lot. And this is one of the most important parts of the session, so just please pay attention. If you were to go back and say, well, how is it that you were able to process either that bar graph in that spreadsheet quickly or that image, is because, again, going back to brain science, there are 2 ways in which you process sensory information, like sight, right? There is 2 very simple forms. There's one is called pre-attentive processing, the other one is attentive processing. So pre-attentive processing is what I said is subconscious, it is fast. It is you're recognizing an image, an object that you see, and you don't need to actually process, you know instantly what is what. A lot of the foundational design and groundwork that is done in visualization, especially for the charts, why bar graph? Why not a twisted line? Why not a cloud? Why certain graphs only? Is built on this principle. And we have about 12 plus attributes that we all are born with. In fact, this is stored within our long-term memory, right? That we can process really quickly and nobody needs to tell you. This is subconscious. This is stuff that we're all born with, right? And these are these 10 attributes, but they're also additional. For example, animation is another way of doing pre-attentive. Anytime you see an animation, you can point it out. The point about pre-attentive attributes, you can spot what is different in the list of things that's given. For example, color hue. Hue in a color basically is the dominant primary color in a set of colors, right? So we have 3 primary colors: red, blue, yellow, and then you have violet, green, orange as the secondary colors. Hue is the dominant color in that spectrum of 6 colors. So here you see that there's orange or yellow, whatever is the color here is the dominant color. Color intensity, this is what is, so you know instantly this is lightened out. You immediately know that, like, you don't have to process each one of this, right? You get what I'm saying? Like, you instantly know this is at an angle, you know there's a different shape, This is bigger, these ones are longer than these ones, and this is wider. And these are the attributes on which our data visualization graphs are designed. I mean, this is the foundation for your bar graph. Why do we have bar graphs? We have bar graphs because we have the ability to look at two lines and we know which is longer, which is shorter. Why do we have scatter plots? We have scatter plots because we can look at spatial positions very well. We know which one is not aligned. We can spot if there's a bubble which is bigger than the other. Right? We can color code different elements within a graph. Why? Because our eyes are able to spot different colors. Now, if I had 5 or 6 different colors, I would have a problem. But then if I want to call one thing out, it's very easy for me to call one thing out because our eyes are, we have the ability to process what is different. Likewise, color intensity, you don't want to show what is not important, you can shade them out. Orientation, like slope graphs and slices in a pie or a donut, you can look at a pie chart and you can say which is bigger than the other because of the orientation of the angles within the pie, right? So that is an attribute that you're born with. Curvature, again, there are graphs with like a radial chart and things like that, where you have curves within a particular visualization, you can make out that this is better. So the point is that all of us are born with these pre-attentive processing attributes, and these attributes form the foundation for the different charts and graphs that we have. There are some complex charts and there are very degrees of accuracy that is built into these graphs, but this actually forms the foundation as to why these charts exist, the ones that we use, is because our ability to process these. And unfortunately, not all charts are the same level of effectiveness. So Suraj, launch this poll. So just take a guess. So I have profit and I have revenue. So let's say you put together this presentation, right? This visualization. The boss asked you, show me a visualization of profit and revenue. So the idea is, how many times is profit as revenue? What do you guys think? Okay, that's actually right. I mean, the answer is I don't know. I just drew two circles. I actually don't know how many times is one the other, is because we unfortunately are born with, we don't have a very good sense of accuracy when it comes to figures with curves, right? And so when it comes to comparing one with the other, there are certain attributes which we can process much better than certain other types. So if you were comparing two numbers, you're comparing two numerical values, there are certain attributes where a user will get things very quickly compared to certain other ways. Like, for example, position on scale. Let's say I give you a scale, right, with markings like the way we used in school and colleges, and I asked you to write, like draw a line which is one is 9.2 mm and the other one was 9.1 mm. You would be able to accurately draw, right? Because you have a scale and then there is a position on the scale and you'll know exactly what is what. And that is the most accurate. And then what you see below are the ones where the accuracies drop. If I just give you length, two graphs without any axis, very difficult if you have fractions. Slopes is even more harder. If I give you two angles, you don't know if it is 47 degrees or the other one is 94 degrees. Again, we know approximately what ballpark it is, but we don't know what is what. It's same thing with angle. Area is the example that we just gave. And one of the reasons why, if you want to compare two numbers and want the user to get a very accurate number of what is what, you don't want to be using area. You don't want to be, and one of the reasons why we don't use, for example, charts like pie charts. If there are a lot of numbers, we give them proportions, but then if you want actual numbers, we use better off with a bar and the others. Volume is even harder because it is three-dimensional and you don't know what is in the back end, right? So you really don't know if what is the area of this versus the area of this. It's really hard for you to, you might even somewhere get an approximation on this, but it will be even more harder for you. Colors saturation is another thing. If I give you a very light shade of two colors, like these two colors, and if I use that to compare quantities, you really wouldn't be able to know how much more darker is this green compared to this lighter green. And so the idea being that when you are using those pre-attentive attributes, bars, scatters, angles, slopes, circles, areas, and things like that, and you're trying to use it for certain visualization of comparing certain things, there is a certain order in which certain visualizations will work better and certain will not work better. Again, there's a lot of science behind this, and you can use these best practices. If you don't know what to do, just stick with a bar graph. You cannot go wrong with the bar. That's why you see so many bar graphs in most of the visualization. It's because it's very easy to understand. If I give you a slope graph, like the way we'll see soon, it's not going to be easy because people don't get angles and the inclinations as well as, for example, length or position. Okay. Let me just see. There's a question. What is the adoption of BICS in Indian corporates? Prathul, when you say BICS, are you talking about BI cloud service? What is BICS? Prathul, if you're still there. Business Information Communication Standard. I wouldn't know. I wouldn't know with an Indian context. I mean, I don't have a measure to say how much it is adopted, how much it is not adopted. I unfortunately don't know the answer to that. Okay. All right. So let me walk you through some historical context. Right? How did this come from? Where are we today? Where is this going? So the very first visualization, or one of the earlier visualization that came, was from somebody like this guy called Michael Florent van Langren. He's a Flemish astronomer. What he wanted to do was he wanted to show time zone differences between different cities. So this is Toledo in Spain. What do you want to show is Rome in Greece or Italy, wherever it is, and the different cities that are there in between, and then how much do they vary in terms of time difference. And he used a multi-dimensional visualization. Right? So you see this got places, it's got the time difference, and he also, I believe, gave reference to the astronomers who came up with the accurate calculations along with this. So you have 2 or 3 different data elements here. One of the earliest form of visualizations. And then this is another famous story. A lot of you might already be knowing. Sulochana asks, how should we be telling a story visualization? We'll come to that, Sulochana. That's one of the things that I want to talk about right after this particular piece, and we'll try and get there as quickly as possible. So he's Jon Snow. So he was a doctor in London, and he wanted to highlight. Actually, this visualization was not created by him; it was created after his story. But then, the idea is that when the cholera outbreak happened, people thought it was because of air, but then they use this visualization to communicate the fact it's not air, it is water. And the way they did that is they had these strip plots where each strip would highlight the number of people who died in that area in with this geography, and then you'll see all of this represents the number of deaths that you see, and then you could see there's a cluster being formed around a water pump, right? And so he made the case, rather the case was made that this water pump should be closed, and then that will reduce the deaths, right? So this is a visualization for that, very famous visualization used in the data visualization circles. This is another third one before we go to the next one, which is again is known to be one of the well-designed visualizations for a long time, which is the Napoleon March to Moscow by Charles Minard. Charles Minard was a railway engineer in Napoleon's army. And what he wanted to talk about was, again, it's a long story, but I'll make this short. What he wanted to talk about was the path that Napoleon's army took from France all the way till Moscow. And while they were taking this path, the Russian army started depleting all the resources, and therefore the army string grew, reduced in size. A lot of people died. And it also grew colder and colder and colder. And by the time they reached Moscow, they were a very small size compared to what they had started off with. And then they returned back from there. And this tells again how the army further got depleted and the path they took back here. Right? So again, a concept of multidimensional information, not bars and all of that, but you see the use of size, width, and all of that to represent magnitude and strength, right? And then this was again a few centuries back, and then in the 80s we had Edward Tufte who came and he said, he laid down a set of rules for visualization, some of which is very relevant, some things that you should follow. I'll give you some examples. So one is, graphical integrity. Like the moment your graph should tell the truth. They should not cherry pick. They should not only pick things which is wrong. They should also pick things which is right and complete, right? So here is an example in the chat. Can folks tell me what is wrong with this with this graph? So this is Steve Jobs, the late great Steve Jobs, presenting the US smartphone market share across different vendors, right? So like BlackBerry, Apple, Palm, Motorola, Nokia, and others. Is there anything wrong with this pie chart in the way it is being displayed? Anyone? Doesn't total to 100. Sumana says doesn't. I actually haven't counted. Does that not total to 100? Exact 100 maybe. Others category. What is the 50% doesn't show, right? Pratil says others category. So this is others. What is the problem with the others category? Not sorted properly. That is actually show smaller play with lower categories, but others. Okay. Kajal says not sorted properly. That in fact is one of the problems. The best practice in showing pie charts is it should always start from 12 o'clock, and then it should, as much as possible, it should be sorted in the order of higher magnitude to lower magnitude. Pies are not in right measure. Jamie, what does that mean? $19 versus $20. That's exactly right, Kumaran. So one of the inherent problems here is by tilting this, showing the depth of the piece, it doesn't it make this 19.5 look bigger than this 21.2? This does not have the depth. This slice of the pie does not have the depth, but this has the slice. This has the depth, and therefore visually you feel that if for example, if we didn't have these numbers, you'd probably think that this green is bigger than this purple. Right? And when you're in the business of data and visualization, you're expressing numbers and communicating this to people. You have to make sure that the graphical integrity is maintained in the data, right? And always show the right numbers as much as possible. Tufte had like several different principles. I'm just going through a few. The second was data to ink ratio. So let's say you have two examples. This is low data ink, this is high data ink. Which of these is easier to read as a user? Money says Steve is clever. Yes, Steve was clever. Genius he was. Charu says first one is easier. Why is first one easier, Charu? Grid shows up easily. Okay, maybe in this the background, if I didn't have white, if I had maybe something else, that's easier. But the first one to say the first one is easier to read. A lot of folks, I get a split decision between the first one and second one. Maybe this is not a good example. The point that I'm trying to convey is that the amount of ink that you use in a graph, you should devote as much of that ink to the data as much as possible, right? And so, for example, you look at this color in the background and you look at these lines, right? These are visual elements that your eyes still have to process, and they have to understand what is it, and then they may not. It creates a little bit of an overload. So this is like additional data that needs to be processed for somebody to see. But if this was on a slightly different background, not white, you probably would have got. But at least these lines, right? These lines are redundant. You don't need these lines to be here. So that's the whole concept of data to ink ratio. Data to ink ratio is the amount of ink that is there in the graph that is representative of data. So if you had a ratio of the data, the ink that is used for data divided by the total ink, that should be as high as possible. Right? So that's the general principle. Remove redundant visual elements that are not adding value to the visualization. Third one, eliminate chart junk. can you tell me from this graph in the month of April, which was the highest selling, which category had the highest monthly expense? It's almost impossible to answer, because this is rendered in a way which is 3D, and then these lines have, different kind of dimensions and depth to it. These are all things that is tilted, and then I don't know why this is in this way. This is what is called as chart junk, right? So visual elements that are not necessary to comprehend information. In fact, they confuse the user. So you should remove, just like design, the idea is to remove stuff and not add stuff, right? So that's chart junk. Fourth point, data density. Data density is the amount of data that is displayed to the total size of the graph. Now, if you compare, so what do you see here? Again, going back to this concept of visual literacy, right? You see two line graphs, but try and make sense out of it, right? So what are the x-axis? The x-axis February, March. So there's a skip of a month, which is fine. So it's going from February till October, and this is skipping multiple months. And then you see different slopes of angles. Then here I have what is called a shrink principle. A shrink principle is, see, this is taken this much of space. The density that is in the space that is taken by data is just fairly high, and this is fairly small, right? So for the total size of the graph that you're using, how much of data that you're displaying, there is a lot of space here, but there is very little data compared to this graph, right? And I'm still able to convey an accurate picture using this graph compared to this graph. And so data density is important when you're showing graphs. Use shrink principle to try and shrink things as much as possible so that you're able to create a more denser factor to the total size of the graph. And the last one is small multiples. The concept of small multiples is, let's say you had a measure and you wanted to show it against different dimensions. Instead of showing how many of you have seen, right, a line graph with 5 different lines on one single line graph? And that's not easy to understand, because lines can sometimes crisscross and you'll have to compare one with the other. Instead, the idea is you take the same measure. So the measure here is daily cases of COVID per a million population, 7-day moving average. And that measure you plot against different dimensions. If I were to plot out all of these 16 in one single graph, or even half of it one single graph, you will not be able to make sense. By plotting it differently, you're able to compare. You're able to contrast measures across different dimensions. For example, you can look at areas where there is a double peak. For example, Finland had a double peak. Czech is declining down. This is going up. Spain is at the point when this was taken, which is March of 2020. Right? So small multiples, you can see series of same graphs in more than one vision. So that is important. That's why James says spaghetti. That is right. Spaghetti chart. You don't want to be having that. So that's from Edward Tufte. And then the actual standard came in I believe in early 90s, mid 90s or 2000s, when we had Leyland Wilkinson. He was part of the Tableau board, one of the co-founders, if I'm not wrong. He came up with a specification, right? A specification on how libraries should develop visualizations. And he came up with this 7-layer cake approach of, how do you take your data? How do you put the aesthetics around it? What scales they should use? What objects are relevant? What statistics and measures can you show? What visual facets can you apply on top? And what is a coordinate system? And so any library graph that you see today, I mean, you see here, this is some of the libraries today that all grew from grammar of graphics. We've all heard of this. Some of you would have heard of this. In fact, Tableau is built on top of grammar of graphics, right? So, and like a lot of other libraries. You would have heard of this library called ggplot, right? A very famous visualization library, ggplot, ggplot2, ggplotly. This gg actually stands for grammar of graphics. And so these are all libraries that are built on top of this. Very complicated to understand, but then if you're in a company which is building visualizations, and these are the ones that you'd use this to build grammar of graphics for your library. Okay. All right. So before we get into visual design, I'll just address a couple of questions. We will take a small break. Sharna, is that fine? Take a 10-minute break. It's 11:30. We meet at 11:40. Is that fine?
Manjunath, you want to take a break? Sorry.
Yeah, I was thinking maybe take a break. It's been 1.5 hours, just for the folks to grab a cup of water or something like that.
Yeah, I think everybody can get themselves grab a cup of coffee. 5 minutes?
5 minutes is fine. So we'll come in back at 11:35.
Perfect. All right, everybody, grab yourself a quick cup of coffee and we'll see you in 5 minutes. Yes, Mahesh, is there anything I can help you with? Can you please put it on the chat window?
All right, let's resume. So what I want to do now is quickly go through the next 15 minutes, some of the basics, and then we'll spend the last 1 hour doing some hands-on, creating some visualizations, storytelling primarily, which is a super important concept in this, right? Just want to check, has anybody been able to install the software, and have they brought it up on their environment? Sonia, great question. So though AI has helped in creating this new data field, is it possible new technology advancements leads to no human interaction in visualizations, or developing skills implied in multiple application in all different commercial industries and must. So when you say, when you say no human interaction in visualization, can you elaborate that on a little bit? In the meantime, if anybody is had the tool up and running, please let me know. I will let you guys share your tool, and we'll do something hands-on in the last 1 hour. Participants, anybody's been able to do it? Pratul says yes. Okay, awesome, excellent, Pratul. So will you be willing to? We'll do an exercise a little later on. Will you be willing to like share your screen and I'll guide you through it. Go through from there. Okay, sounds good. Excellent. All right. Sonia, I'll come back to your question once. Okay, software tool which automatically, yes. We'll actually see that today. In fact, that's the piece that I would like Pratul to show. So once we get to the tooling aspects, in fact, all tools support this. They all support the ability for automatic explanation of insights on data, where a user does not have to go manually dig. The system will tell them what is happening. We'll see that. We'll see that very shortly. Asit, okay, great, Asit. Awesome, very nice. All right, so let's quickly, another 20 minutes, and I want to spend at least an hour with some hands-on stuff, right? So that people can follow, they can see how to do this. We'll quickly go through the design and charts, and then we'll jump into the storyboarding, where we'll actually try the hands-on. So one of the key things in visualization is a mistake that we do, just like I've done this, and I've seen a lot of people do it. Just like presentations, we emphasize too much on the design and aesthetics over form, over fact, right? And so, but it's always important that, just like in presentation, it's the target which is more important. So you have to work backwards and see who's the user you're creating the visualization for, what data and attributes does he have or he or she has for the visualization to be created. And sometimes, or often most cases, you will have more than one chart, which is the right answer for creating the visualization. But you'll have to pick the chart which is the one that is most relevant. I'll give you an example. I'll jump this and I'll give you an example. So let's assume somebody, they asked you to create a visualization on hierarchical data or relational data, right? There are three ways in which you can do this. One way to do this is this visualization called packed circle. So a packed circle visualization. So what this is giving you, I don't know if you are able to see, but what this is telling you is the movie production box office numbers of different production houses, and then what are the genres in terms of different movies they produce, right? So Warner Brothers, Disney, Sony, Summit, Independent, Universal, and so on. So you see there's a hierarchical relationship, right? You start from the production house. From there is genre. In each of the genre, you can see different movies, right? And the size of the circle represents the number that it produced at the box office. So this is called a packed circle. Another way to do this is something called sunburst. Sunburst is a chart where you see a radial outward flow of the same thing, right? So here, instead of circle, you have these sectors of the production houses. Outside of that, you see all the different genres. And then from the third circle, you see all of the different movies, right? This is another way. Now, there's a third way, which is, there are only three ways, there are multiple ways, but then in the case of the discussion here, the third way is tree map. This is a visualization that some of you would have been familiar with. Quick trivia: does anybody know why this is called a tree map, or why is a when you see this? Why do you think this is called a tree map? Post your question on chat or Q&A. Camera is off. Sorry about that, Suraj. Q&A or in chat. Why do you think this chart is called a tree map? Just trying to get you guys more involved. So the answer is, this is kind of like, you see a tree. What do you see? You see a trunk, and then you see branches flowing, right? Then each branch has sub branches. Those sub branches has other, more branches. The concept of in the world of hierarchical relational data, it's the same thing, right? So you start with a root node, and then from there you have sort of child nodes. Then from those child nodes you have further nodes. So this is called a tree map because it represents hierarchical data. So you start with one box, and then that has multiple boxes underneath, and it has multiple boxes underneath. The significance of a tree map is it gives you relationship. It gives you nested relationship between something. So think of like in your Windows, in your machine, your Windows Explorer, right? When you expand on your folder structure, you start from your root folder, and you see what is underneath, what is underneath. Think of a case where you want to look at product categories, the revenues by product category. Product catalog is typically a hierarchy. You start from the root cat of the product catalog, from there you break it down into, for example, your servers, the desktops, and all that. And from there you get into actual products, and then you want to look at revenue numbers. So this gives you hierarchical relationship data. Then it tells you visualize how the composition of that particular node is made up. Now, each one of these, let's say the user wanted this, each one has its own pros and cons, right? For example, in a packed circle, what is the problem with the packed circle? It is very, again, couple of problems right up front, right? It's very difficult to compare sizes, and it is almost impossible to go beyond. You really can't compare this one with you can hardly see, right? And the second thing is not very space efficient. In fact, that's the only difference between a packed circle and a tree map. The difference between this visualization and this visualization is this is space efficient. You don't see any loss in space in between, right? And it is using rectangles for its shape here. Everything is a circle, but then you see there is space is not efficient. There's space being wasted here. Sunburst actually solves some of the problem in packed circle, where you can actually see the levels. Now imagine if this had 4, 5, 6 levels. It's very difficult to even see that are there, how many levels are there. The question was how many levels are there within the hierarchy. You can always answer that with a sunburst, no matter how many levels are there, even if it is 5, 6, 7, 10 levels. Because the outer level keeps growing, you can actually count the number of sections here, and then you know there are these many levels. Again, it is not very easy to compare and contrast and things like that. If you want to look at actual numbers and things like that, again, this is not the visualization for it, but kind of gives you a rough approximation, right? But slightly better than a packed circle. Tree map, like I said, is nothing but a packed circle, but instead of a circle, you're using rectangles. Rectangles give you a better visual accuracy for comparing two different boxes as compared to a circle. So your accuracy level will be higher here than higher here. Now, a user may have a certain preference. Certain users might say that I like tree map because it is not too complicated. My data does not have more than 2 levels, and I don't have too many first level nodes, right? And so this is fine for me. If the data has a lot of levels, and but the number of nodes in each level is less, then maybe sunburst is better, right? So the idea being that what visualization you pick and design depends on those 3 factors. One is who is the user, whom are you presenting this to? 2, what data do you have? What are the constraints of the data? How wide is the data? How spread is the data? What are the data elements? What are the data values? Nesting, depth, all of that stuff. And then 3, if there are more than one choice in which you could do the visualization, what does the user want, right? So again, you typically what you would do is you would do this, you go to the user and say, I have these 3 options. What do you want to pick? Then you give them pros and cons and they pick. That's typically what you do. And again, going in the concept of design, there's this thing of visual hierarchy. You see a lot of these dashboards where everything is placed next to each other. Sometimes you might want the user to see certain things that you want them to see first. And we do this using this concept of visual hierarchy, right? For example, if you take this, your eyes will go here first, because this is the biggest, boldest, and right in the middle. Then you see this, then you see this, and then you see this. Now this is important because if you're creating visualizations, and if your visualization has 4 or 5 different charts, but you want to control the user in terms of how you want the user to navigate. Typically users will always start with bottom, top left, and then they will go clockwise. But you can control what they see first, what they see second, what they see third, using these visual hierarchy concepts, where you using size, shape, colors, you can guide them to what they see. If you don't want to use size, you can use colors. Like for example, here your eyes will either go here or you will go here. This will be your top two, and then you will go here, then you will go here, and then you rest of the things. And this helps you in prioritizing what your user should see first and what your user should see first, right? So that's again, make sure when you're creating visualization dashboards, and you will see in a lot of these dashboards, everything is at the same level, same size, same order, same background, same color. And then the user's eyes are going all over the place and they really don't know what to see. The brain is confused. So you can avoid that by breaking this down into these things. The third concept is Gestalt's thoughts of visual perception. I think some of you might know this. Gestalt came up with this concept that depending on how you want to position, how users perceive certain things based on these parameters, if they're if you keep things close by, they think they're part of the same thing. So if you have a visualization in which let's say you put 4 different graphs next to each other right on top, they will think that they are all kind of aligned on the same level at some point, right? You can use different colors and shapes to identify which is similar, which is different. You can put an enclosure in the background to say that these 4 are the same connections, different characters. Can somebody tell me what is figure and ground? Put it on chat. What do you think this is? Jar and two faces. That's exactly right, Kumaran. So if you see from here, you see there are 2 faces facing each other, but then you see in the background it's actually a vase like structure, right? So you can define a lot of the logos are defined this way, that they define such a way that you're able to communicate 2 different things with a lot of meaning and stuff. So use this also in your visual design. Okay, let's get into chart selection, and we'll jump on to storytelling and actually creating some projects. Prathul, maybe you can bring up the tool and just launch and keep everything ready. And we'll start with this. And then we'll do one more session with one more exercise with Asit after that, if time permits. Now, how do you select different charts? Right now, there are different ways. The quickest and best way is you let the tool decide. All the tools that are available in the market today, that they have the ability based on the data elements that you've shared. Is it a metric? Is it a measure and a dimension? As a 2 different metrics? Is it 2 measures and a dimension? Is there a time level component? Is it over a period of time? It has the intelligence built in to pick the best visualization for the data and the data type that you've given. But if you wanted to control some of this or understand how things have to be built, you can control this yourself, right? Like for example, one guidance way, and there are different ways to do this, but there is one way to guide this, which is what are you trying to do? So ask yourself, what are you trying to do on the data? Are you trying to compare 2 things? Do you want to show that product category A revenue is bigger than product category B? Are you trying to show distribution, how data is spread across different bins? Are you trying to show composition? What is the contribution of different product categories towards revenue? Or are you trying to show relationships? As the temperature in summer increases, the ice cream is also increasing, for example, right? You want to show there is a positive causation relationships, and or not, right? So let me show you a couple of examples. This will give you guys preview into the tool. Let me stop sharing and launch my tool, and then we go from there. Where is it that I have? Okay. So a lot of again, I'm using Oracle data visualization in the tool for me here, but a lot of the tools work in the same fashion, right? So we're using Tableau, using Power BI, any of the commercial tools, they all more or less have the same way in which they work. Some tools may have more broader, more in-depth features than compared to others. But in terms of getting things off and going forward from there, 90% of the stuff can be done by most of the tools that you see available in the market. So let me just take an example. I have to share my entire screen. So let me share my entire screen. And then we go from there. I just want to show you, for example, how do you pick? Let's pick the first one. Let's say I want to do comparison, right? If I want to do comparison, there are, again, how do I want to compare? Do I want to compare? I want to compare among items, which means I want to compare between, I want to take revenue and then split based on different product categories. But then I also have, different variables. There's more than one variable. So this is called a variable width column chart, where the width of the column is different and it represents another dimension. So the size is a third dimension in a 2D graph. If there are many categories, I can put them in a scatter, fewer categories. So let me actually show you these four real quick, and then I'll show you some of the others as we go along. Right? Let me quickly check on the questions. Pratul, awesome. That's brilliant. Very nice. Okay. Very good to hear, Pratul. Truck to leaf size mimic. Vijay, I didn't get that. What does that mean? Truck to leaf size mimic? Okay, let me launch this, and then we can go from there. So Pratil or you guys will be able to follow, or whoever has installed the tool should be able to follow this. And I'm just using this as an example, but you guys can also do this with any tool of your choice or anything that is used by your companies or any of the commercial tools and so on. Right? So let me walk you through the first example. The first example that we talked about was this, right? So I want to compare. I have two variables per item, and I have a variable width column chart. Now, what does that mean? What it means is, let's say I want to compare sales. I want to compare it based on, for example, product category. I can either say create best visualization, in which case that's what I said, right? They will pick the system will pick based on what you pick. So here I have a measure and I have an attribute. It has automatically given me a bar graph or a column chart. This is either called a column chart or a bar chart. Typically, people use bar for horizontal, column for vertical. Now we are talking about variable width. Now what this means, so what this is saying this is the sales by these different product categories. But if you see, the size of the bars are the same. Now you can add a third dimension to this, which is the number of quantities sold, right? So if I have, for example, quantity, I have something called quantity ordered. So I have an attribute called size. So I can add this and drop this here. Now what happens here is, now you have three different bars. They all show the numbers, but the width is also different, which means now you know that office quantity had the highest number of quantities that were ordered, and then technology, and then came furniture. Now you can color this. For example, if I wanted to maybe color this by product category, I can call this by product. So that's your first one, right? I'm trying to compare values, and I'm trying to show two variables per item. Now, what are the two variables that you're showing here? You're trying to show sales, and you're also trying to show order quantity. Right? That is one way. Now, if I wanted to do many categories, I want to show this across many categories, and what you do is you do something called trellis rows. So I can, for example, make this product category as a trellis column. I can make the product subcategory as a trellis row. I will remove this. So now you have different product categories, and then you have product subcategory. I'll probably add product subcategory here. So now you're able to break this down by different numbers, right? So you can see the numbers based on for that product category, for that subcategory, what is the sales number? And that is this piece. You have different boxes in which you can show different graphs. If you have fewer categories, you can do this thing called horizontal bar chart. So in this case, let me delete this. I have, for example, I will pick sales, and I will pick customer segment, and I will force a horizontal chart. So this is, I want to compare, but I don't have that many categories, right? I mean, customer segment here is anyways fine. But then if I have fewer categories, I can use a horizontal. Now, question in the, would it be possible to share the current slide composition? Yeah, absolutely. I will share the deck, absolutely, no problem. For folks, so quick question for folks on the call: when would you use this versus if I were to say, let's say I put this here and I make this right. So the question is, when would you use this and when would you use this? In other words, have you followed at any point in time any principle or any best design guidance on when you should use a horizontal chart versus when you should use a vertical chart? Because you've seen both of these, right? Mahesh says tracking horizontal, less items on y-axis, x-axis more items, it's better horizontal. Mahesh, can you explain what does tracking horizontal mean? Less items on y-axis and x-axis more items, it's better horizontal. Okay, it's not a wrong answer. Horizontal for timeline, vertical for progress. That is actually one of the right answers. The idea is that you want to use one of the reasons when you pick this over this. Actually, there are two reasons I can give you. In addition to the answers that the folks are given on chat, right? You will use this if, for example, you want to keep an order, right? Your x-axis is a variable where there is an order. For example, let's say it is a survey scale, right? You have strongly disagree, neutral, agree, strongly agree. Let's say those are the 5 values on which you got responses. You would want to maintain that order here. So that, I mean, in other words, any ordinal value, time series, any scale of measurements, temperature, Likert scales, anything that has an ordered set of values, you want to keep them in the horizontal here and then let the flow be. One of the things you can do in the vertical chart is you can actually play with the sorting order. Typically in this, what we would like to see is if it is sorted based on a specific fashion. You want to see things from highest to lowest or lowest to highest, whatever the case may be. But then you don't want to do that sorting here, right? Because that will mess up the sequence. You might have 4 coming in first and then 3 and then 1 and then 2, for example. So anytime you have an ordinal variable which has got a values in a set of sequence, you use this vertical bar chart. Anytime you don't have an ordinal value, but then you want to be able to sort on your measure, you use your this horizontal bar chart. Depending on landscape and portrait pages, that is also true. That is in fact the second thing. Now, one of the advantages that the horizontal chart brings is that it will not truncate, or it will not cut off the label here. It will use as much as space that is required for the label, but sometimes you may have label problems here because this has only this much of space for the label. Right? So if you have a long label here, then this will not show up completely, especially if you have a number of values. In that cases, this is better, that you can actually show different values for the labels. Brain seems to digest faster the horizontal than mine. No, that's actually not that's not wrong at all. Somehow I like the horizontal one better than the vertical one, because maybe it's the way we see things, right? Especially because I'm sorting. When I sort, all I want to know is what is my top 20%, for example. I don't want to look at the remaining 80%, in which case this actually works better. Right? So that's your horizontal. So I just want to give an example just for this comparison for these pieces, right? So if you want to compare, you can use these kind of graphs. If you want to compare over a period of time, you can use this, right? Now, let me ask you another question. If I were to change this, if I were to change this to a line, is there anything wrong or right about this graph? Can we add time dimension? Yes, absolutely, we can add time dimension. What is wrong with this graph? There's something seriously wrong with this graph. Line is for trends usually. There's a lot of empty space. Line is for trends. Usually that's the right answer. There's a lot of empty space. Okay, we can fill up the space. The problem is in the grammar. Visual grammar is very important, right? And this again, it talks about why that grammar is to be used. Just like English grammar, you can't use certain words in wrong places. The reason why this is wrong is this is not a trend, as in this is not a continuous line. Think about a data point between consumer corporate. What is that? Is that consumer or is it corporate? Right? So the general rule of thumb is this line graph should only be for anything which is like a continuous scale, a continuous variable where you have points in between, like time, temperature, scales of that kind, right? Where you can connect the dots anywhere in between. This is not a continuous variable. Between consumer and corporate, if I were to take a point here, what is this? Is this consumer or is this corporate? So be wary of line graphs where the x-axis is not a continuous variable. It's a wrong way to display value. Right? Okay, flipping back. Now, you want to compare over a period of time, use x-axis. So instead of this, if I were to drop, for example, I don't want it to be customer segment. I'm showing sales. Maybe I want to show this based on order data. Again, I have my time dimension here. To Sumina's point, I can break this however I want it. So let's say I want to break this by month. I can just drag and drop it here. This gives me a trend of how the sales has been for different months. Again, you can do filtering, all of that stuff. Again, all the tools support all of this, nothing which is specific to this particular. Okay. So you have over time, you can do different things. You can do based on cyclic data. Cyclic data is like a clock in your watch, right? Starting from 12, you can have your different quarters and you can see how things are popping. You have non-cyclic, if it's linear, you can have a line graph. You can also use bar charts, different quarters on x-axis, and you can have line charts for different x-axis. Connector between 2 points. Yeah, I think these are the answers, I suppose. I'm just looking at the Q&A now. So that's for comparison. Again, distribution is how are the points distributed over a period of time. The ones that we've normally used is histogram. If you don't want to see these bars, if there are way too many points, then you use a line, right? So you just connect the top of the points. So this graph is formed by just connecting the midpoint of each of these bars. Okay? And you see how all of this is, again, built on top of the pre-attentive attributes, right? Your lengths, your positions, your size, your colors based on hues, angles, slope, majority of the charts that people understand are built on the concept of pre-attentive attributes. That's why that is so important for us to understand before we go here. So that's for distribution. The different points spread over a period of time. You can either use a histogram or a line point, or you can use a scatter plot. If you're looking at composition, composition is like your pizza, and what are the different slices in that pizza, right? So the different ways to show composition. So I have, let's take an example. So I want to, let me just delete this. Okay, actually I can pull in. So I want to show sales, but I want to show based on subcategory. I want this to be a bar. Actually, I want this to be a stacked bar. And then I will show I will add maybe the ship date. Actually, I can add the product subcategory as well here. What am I doing now? 100% stacked. Actually, let me start from here. I can color it by subcategory. I can remove product category. Still not seeing. Total sales by. Okay, I'm not able to pull it out here. It froze for whatever reason. The idea is you take a particular component, you show that revenue number divided by the components that it is part of. So if I add sales, then show the split of sales based on different categories that are part of. Now you can either use 100% stacked bar, or you can use not 100% stacked bar, in which case if you don't want a relative or absolute measure, you split that up. Now the difference between area chart and this is just that the area is just using the connecting all of these points into one area. That's all the difference. This gives you more concrete definitions on the points, whereas this gives you approximations. Pie charts is notorious for these days they're typically not used for showing different slices. The general rule is anything beyond 5, you don't show pie charts because very difficult for people to compare, right? Then you have waterfall, which is it tells you what is the previous value, what is the current value, how it is progressing. Then you can use stack bar. Relationships, typically it is scatter, right? There are two kinds of scatter. There is scatter, there's scatter cat. Scatter cat is when you have trying to measure a related variable with dimension. You're trying to show with two numbers. So if I just want to show how is my cost varying with sales, then I would just use a scatter plot. Okay. Then I will share this these slides with you. You can take a look at these different other slides, different kinds of charts that one can put together. This is all coming from the source called ft.com. You can actually go here right now if you want. This is financialtimes.com/vocabulary. There are different ways in which you can show different meanings. I can show deviation, how much is one varying from one to other. Nice way to show, for example, surveys. If you had surveys and you had yes, no, neutral, you can show diverging stack. Spine. So this is what you've seen in cricket matches, right? When there's a partnership and you want to show how much did one guy contribute, how much the other guy contribute, you can do that. Or you can show split between genders, male, female for response, all of that stuff. Correlation, like I said, it's all scatter. What is the relationship between two variables, and not necessarily causation, but how is if you increase one, is the other also increase? That's correlation. Typically, scatter and bubble is what is used. Ranking is comparing two things, but which is greater, which is shorter, right? Typically bar charts, but you also use scatters with size as a dimension. If you have bigger the size of the circle, then you know that is bigger. Slope is not something that people generally use, but it's a very nice chart. So the idea of slope is to take something to show before and after, right? So if I have, so this was the first number value, this was the after, and this tells you whether if it is going down, that means the value went down. The slope goes high, it means it actually went high. So so let's say you ran a campaign. We see this example shot. You ran a campaign, you picked one number before, and you picked one number later, and you want to show what is the change in how much did it change. The angle of the slope will tell you how much did it change. And there's lollipop, which is a variation of your bar chart, and then bump. So this is ranking. Distribution, again, we spoke about, right? How is the value of something distributed over a period of time? The advanced visualizations are things like box plots and violin plots. This will give you, if you had a lot of data points and you wanted to know how are the values distributed over the scale, whether it is axis or bins, this will give you those two. And we'll see an example for this barcode plot in a second. Again, there are a lot of different graphs. There's no one particular graph better than the other graph. The general guideline is to go with the pre-attentive attributes. Anything with those ones should be a first choice, but then you always go to your user and say, look, what is it that works better for you? Based on that, you pick the right one. Then change over time. It's always x-axis is always the y-axis. The only time when you have x-axis on the vertical, there's also something called vertical timeline. The only time when you use this is, for example, you're building a visualization on a mobile. Because on a mobile, it's easier to scroll down than to scroll across. And so if you're building visualizations specific for a device, the timeline is actually on the y-axis, not on the x-axis. Magnitude, which is, again, we use the variable width column chart, if you remember, that is magnitude. How much does it represent? The ones that are, the interesting ones are something like bullet. A bullet chart basically gives you, is like a bar chart, but in the bar, it gives you multiple data points. It will tell you what is the average, what is the target. Let's say you are trying to measure the sales for the quarter. On the bar, you can actually put an indicator to say this is the target. And then you can say how much of the target has it actually achieved. What is the average value, for example. You can do all of that stuff within one single bar. So bullet is nothing but a bar chart with multiple kind of data points in between. Spatial is everything to do with geography and locations. A lot of interesting stuff here. I'm not going to go into depth, but you can use chloropets and all of that to show what is the contribution of a particular state or a country towards a particular measure, right? And all of that comes in spatial. Part to whole, again, this is the composition part, and like I said, pi is an interesting piece, but the idea is not to use more than 5. Donut maybe sometimes be better, can show more than 5, and number will be in between. Then you also have these things like Marimekko chart and tree maps to show the composition. If you have a total, and if you were to break it down into individual parts, then what are the individual parts in that component? Okay, so let's get into the storytelling piece. I'll set the context, and then we'll launch Pratul's tool, and we'll show one of the things that I think there was a question, right? I don't know if it was Sumana, somebody who asked, like, can there, or actually it was not, I think it was Sonia, can the tool create stuff on itself? Now, when it comes to storytelling, a favorite topic of mine, in data storytelling, it combines 3 things, right? You combine data, you combine visuals, and you combine the narrative, which is the way to tell what is really happening, right? And there are 2 kinds of storytelling in general. One is called exploratory, which is similar to your exploratory analytics. Somebody is given you a data set, and then you basically explore the data and see what is coming through in the data without you having to do anything, right? So you take data, and then you do visuals, and then you kind of enlighten it. I mean, the users get enlightened by what is actually happening. The other one is narrative or explanatory. Explanatory is when let's say a business user has asked you for some output of, let's say you had your chief marketing officer in your organization allotted, I don't know, let's say a lot of money for a marketing campaign. The campaign ran for 6 months, just finished. The following day, he wants to know how much of business we generated. What then the user is expecting is that you get into the story of explaining what was the outcome of that result and what are the trends that you found, right? So that's the general idea. So in the narrative mode, you have to what insights you've got, and you're trying to explain that insight. In an exploratory thing, you don't know what you're looking for, or you don't have the insight ahead of time, but then you're taking data and you're applying visuals, and you're visually exploring what is happening within the data. You're trying to find visual patterns to see if something is interesting happening that I can know something better by, right? So let's try all the techniques. Praful, maybe you can share your screen and launch your tool, and we'll walk you through we'll very quickly create an exploratory data storytelling style. Excellent. So Pratul, so the idea of me using Pratul on chat, have you used the tool before, or is this the first time?
First time.
First time. Okay, good. The reason I wanted to do this, it's a little risky, but then the whole premise is the tools these days are so easy to use, and it's not just the Oracle tool, but any visualization tool is so easy to use that anybody should be able to pick this up really quick. You really don't need a paid course or a training to actually understand tools, how to use tools. You can do this yourself. A lot of this is self-service. So what I want to do is I want to maybe create, so let's try and answer Sonia's question, right? So can there be ways in which you can enlighten data with whatever is there? So can you open a browser? Let's just pick a data set, right? So pick a data set. So do a Google search saying, I don't know, HR data set Kaggle. We just download some file and then we'll try and visualize it. Just take Kaggle, C-A-G-G-L-E. I mean, K-A-G-G-L-E, sorry.
Oh.
Okay, so pick the first link. Okay, so just click on download. The right side. So what we're trying to do here is we're just trying to pick a data file and we're just trying to explore. So think of this as a scenario. Let's say your boss has given you your data and then said, create some visualizations for me. Give me some insights. Tell me something that I don't know, right? And the idea is how quickly can you do this? And you don't know anything, right? So click on download. So whoever else has downloaded the tool can follow the steps. So you'll be in the same pace as what Prathul is doing. So first thing you got to do is open that file in Excel. HR dataset V14. Yeah, that's the one. Yeah, open it. This is put into comma. So you'll have to now close this, open it again. I think this is comma separated. We'll have to save
That's
this as
what
an
I
Excel.
feel.
Yeah. Okay. So just save this. Just save this as an XLS file, not a CSV file, a workbook. Yeah.
That's what I'm doing.
Yeah. Perfect. No, don't put hyphen, gif, and all that. Just save it with that name. Just rename that. Just remove.
That's what I'm doing.
Okay. There's a lag between. Okay. So go to the tool.
Perfect.
Well, let's load this, right, and see how it works. So you click on create on top right. Top right. Create workbook. Now it is asking you like what is a data set, right? So click on create data set. It's asking, tell me what do you want me to analyze. Click on drop. You can say if you want to, yeah, just pick up that file. Pick up the XLS file or the CSV file. Okay. Just click on enable it on that thing. Yeah. Okay. So can you make this full screen?
That's
Okay.
what.
Okay. So what this is telling you is it has taken the data file and it has automatically passed it in the bottom, and it is telling you what data elements you have, right? So you've got, yeah, perfect. So you can see that it's got employee ID, is marriage, status IDs. Now all of these IDs it has looked at, because these are numbers, it has looked at it as numbers. So ideally, these are not numbers, these are attributes, right? So can you click on employee ID? Yeah, and then on the left hand side, where where it says treat as measure, click on that measure in the bottom left and change that to attribute. Can you do this for all the IDs? Yeah, just click, go to the left, and then just change as, because these are not the reason why you do this change is because you don't want the aggregations to be looking at this into sum monthly. You don't want this to sum up, right? So you want to maybe look at these attributes. So these are some of the data wrangling things that you can do from your side before you start ingesting the data. Okay, performance score ID as well. From diversity, yep. Perfect. So salary is a number, which is fine. Term definition, I think, is also fine. Position ID, maybe we can change. Yeah, that should not be a. Okay, scroll to the right. Now you see position. And what else you have? State. Zip it as text into a number. That should not be a number. So change that to attribute. I think that should be fine. After this, we can. P says many tools are marked as identifiers and attributes of That is right. You're exactly right, Kevin. Okay, so click on, so you have the data here. You just click on add on top. So now what the system will do is running some machine learning tool in the back. Again, all of the tools do this, right? All of the commercial tools do this. Now what this tool is doing is it has run some machine learning thing in the background. It has profiled the values for each one of the columns. It is telling you if there is null. It is giving you some automatic data extraction pieces, like if you want to extract one part of the value out. It is telling I can do all of this for you. Do you want me to do all of this? And you just scroll to the right. What you see on top, you see all those are profile values, right? So for example, you'll see which has got the highest value, what are the values. So all of this stuff you can do, the system has done for you without you doing anything. So just click on create workbook.
Why is it not doing it?
Are you not able to click?
Nope.
Edit. Yeah, that should be, that button is enabled.
I know it is enabled, but I'm surprised. It seems my mouse is gone.
Okay, no problem. We'll wait. Can you use tab? You see tab going anywhere? Okay.
Okay.
Edit. Okay, now you click on create workbook. Can you?
That's surprising.
Just say okay on the next to the table name where it says, just say okay there. Now can you create workbook? That particular button is disabled now.
Yes, that's the button which is creating a problem. I don't know why.
That should not be because you just did everything, right? Can you can't save this as well, right?
That's what I'm looking at.
No, you can't because you have to
First get it into the system.
No, but I don't see the create workbook button disabled, so I don't know why it is. This is interesting. Asit, are you having
Murphy's law.
Huh?
Murphy's law.
Murphy's law. Murphy's law. Can you click on that all steps combined in the bottom left? That apply script is also disabled. No, this should ideally work. Can you go back and start again? Can you click on edit definition? Okay,
One sec.
try that.
Let me start from here.
Yeah. Just click on add to workbook.
That's what I'm doing.
Yeah.
Let me start from here.
You got it here. That's fine. Okay, this is fine. So, okay, now let me expand. Can you expand your screen?
I'm full screen.
Yeah, full screen. And I need to expand my screen. Okay, so on the left-hand side where you see HR dataset underscore 14.
Yes.
So that's your data set, right? So if you scroll below, you will see all the values. Do you see all the number formats have all changed, right? So wherever it was ID, it has changed. Now, one of the things that Sunil asked was, can the system do things for you, right? Can you ask it to explain what has happened? So you can actually do that. So if you scroll to the left in the bottom, just scroll to the left. You can, for example, take performance score just right click on performance score. No, this is not got enabled on. Oh, you've not installed the analytics, unfortunately.
No, I have. The R add-on is installed.
Have you restarted your laptop?
No.
Okay, that's probably the reason why. So let's do one thing. Let's pick a performance score and then pick by manager name. Just select those two things, those two attributes. Performance score and manager name. I think you got to start again. Just go back and create a new workbook. I don't think this is in a state that can be used.
One sec. Let me just restart the application.
Yeah. In the meantime, let me share my screen and I'll explain to the folks.
I'll stop sharing.
Okay. Thank you, Pratham. Once it starts working, let me know. We can scurry back. Okay.
Sure.
Okay. So the way this works is what we were trying to do was, let's say we did the same thing, right? So create project, and I pick a data set, right? So HR 14 data set. This was the one that we just added. And you have the data set added here. Now you can take a particular field and you can say, explain it to me. We say explain. What you're saying is performance score as an attribute. Tell me how does this attribute look like profile in the data. So what, and again, all of the tools do this, right? So what you can do is you can say, like, these are automatic insights that is generated for you. It's saying that, okay, the performance score, there are 4 values: exceeds, fully meets, needs improvement, PIP. And 78% is fully meets, and there are something as well. You see a checkbox here, which means when you check this, you can say, add this to my project. You have not created any visualization, right? And it has taken the same thing and it has measured, compared that with other things. Like, for example, how does performance score compare with the job fair, the place from where I recruited? How does performance score check with salary? How does performance score check with the place? How does a performance score engage with satisfaction? So if I want to do something, for example, here I see that there is a huge PIP factor here. So I can say, I want this to be added to my visualization. I can look at maybe the engagement survey, whatever, whichever you wanted, right? Performance score by job, maybe from where I recruited. Is there anything with salary? And then you can ask for additional details, like, do you want this? Like, it is telling me that performance score, for example, is highest in a particular measure, right? In this particular column, whatever it is expecting something, but something else was there. These are the places in which we hired, and I see that this was the highest, the termination reason for performance score was highest for this. These are the sources from where we hired people, and then looks like website had the highest thing. So I can say, okay, add all of this to my visualization. Then I say add selected. Now what will happen is, now the system has created the visualizations for me. I didn't have to do anything, right? And this is again fully sort of interactable. If I wanted to kind of go down and say, okay, so I see performance score by recruitment source. I see in website I had 2 people. Indeed, I had 5 people. So I can say, right click and say Indeed location from where I hired the recruitment source. Like, who are, like, what happened here, right? Now, if I want to, for example, look at the manager name, I can maybe look at the manager name. And this will give me a breakdown of all those people who lost, I mean, who were in PIP, who are the managers for that came from Indeed, right? I can count. So Michael had 1, John Smith had 1, this guy had 1. This is anyway 100%. So I have Amy Dunn had 2. So maybe there is something with managers that's going on. So can I, for example, then look at performance score by manager? So here is where I can start doing a little bit more exploratory. Can I look at performance score by manager? Right? Let me pick a measure who have, let's say, the highest satisfaction. This is telling me by different managers, how many of them have had what rating, right? And you can, so depending on what is the question that you're asking for. So let's say the question that I'm asking for is, which manager has the highest PIP candidates? So that's red. So then you see here visually, this guy, Brandon Miller, has the highest PIP candidates. Next comes Lynn, then next comes maybe so Amy has a few people. Then Lynn also has a few people, right? Again, the employee satisfaction scores is pretty low, right? So now you know who are the managers who've had low employee satisfaction scores and who had a lot of PIPs. Now you can go and talk to them and figure out what is going on, all of that stuff. Now, what we're talking about in this previous case of what Prabhu was trying to do, and what I was also trying to show. Again, this has got reflected to the previous filter. So I'm just going to go and remove this. So the idea that what we were talking about, let me stop sharing and share again my entire screen, is this concept of explain. So when you take data and you put visuals on it, you can actually tell a story, you can ask it to explain. And this explain is what all of these tools provide. Right? Let me give you another example of how to tell that explain. So let's say you wanted to explain employee satisfaction. We looked at performance score. Let's say I wanted to explain. So you can just, all these tools will support this. You can just say explain. This explain is nothing but this explain. You're taking your data and you're allowing a narrative to be done on the data by putting a visualization. So you can say right click, explain this thing. The system will go through the attribute and it'll figure out how does this attribute relate to all of the other things, right? And what this is giving you is it is giving you the ability to visually explore some things first before you actually do anything concrete on it. If you see any interesting pattern, right? Any particular something that stands out that should not be standing out. For example, is there a reason why employee satisfaction is less in males compared to females? Is there a reason why it varies across marital status like this? Or is there a reason why in certain dates the employee satisfaction went really high, and is the reason why certain days the employee satisfaction was really low? Then you can look at anomalies. These are anomalies where this should not be the case. It was expecting this much, where it was so much. So you can say, I want to view all of this, but I'm not going to create any visualization. So you can say, okay, add all of this stuff, and I just want to get a sense of what is what by department. Is there a reason why in certain departments the employee satisfaction is really low? Positions, for example. Whatever you want to do, then you can say add selected. And what this will do is this will create the visualizations for you. It will allow you to explain the data that you've created based on the visualizations automatically created. And then you can go back and drill down. For example, here I see that this is really low, right? Now I can drill down from here. What do I want to look at this by? What is, I don't know, let's pick any particular reason. Again, pick up, for example, manager name. Who are the managers in this department where it is really low? The people who are really low satisfaction are people who are the CEO, right? For example, in this case. So it allows you to explain what is going on, and then you can, without you having to do anything, you have a visual sense of what is happening, and then you go from there. That is one form of storytelling. Another form of storytelling is just explaining what is happening. Now, this is an example that I got from. Okay, let me just quickly check the questions. Given end users have what are the best practices in PPT sometimes? Okay, so Rajesh asks, given that they have different levels of understanding, what is the best way to convey? Because these tools are so self-service, it is very easy for you to mock this up on the tool itself. You don't have to do a PPT. In fact, when you go to your users, you actually take this and go, and all of these, I mean, you can export all of this into a file and you can do PPT and all of that stuff. But then what you don't do that. What I suggest is you take the tool with you. This becomes your presentation tool. And the reason for this is if they want to do further interactions, drag and drop additional things, right? They can pull in this data here, and that will give them additional insights on what is happening. And then the dashboard gets created, and then you go back from there. So that's the best way to do that. Okay. So in terms of, that is the whole explain concept, right? Of how you tell a story. Another way to tell the story is explanatory, like I said. So this is, you want to get to the point really quickly. You don't want to beat around the bush and go here up and down, all of that stuff. You just want to tell what is what, pick a visualization that explains what is what. Now, this is an example that I picked up from Cole Nussbaum and Affleck's book on data visualization, something I highly recommend you guys read up. So the exercise here is, let's say somebody ran a survey, and then, for high school students or rather for school students in 2nd and 3rd grade. And the program that they ran was they wanted to increase their interest in science. So they wanted them to understand, be more interested in science. And they ran a survey before the program. They ran the program and then they ran the survey again. Now, the person, or the management person who's funded this wants to know, how did it go? Was it a success? Was it not a success? He wants to get insights, like what happened. Now, this is one way to do this. Is this a good way to do this? Or is this a bad way to do this? Quickly on the chat. If you were the management executive, would you be able to say, was this program a success or not a success? This is not a good way at all. It's very difficult for you to compare. You're comparing now 10 slices across 10 different colors and categories. Really can't, like Kumaran says, can't really make a decision out of this. So what are the ways in which you could do this? One way is you really don't have to maybe show a chart. I mean, if all the guy wants to know is, if there's one big number that can stand out, again, use visual hierarchy here. Now put the number in big font, give the outcome right up front. Use a combination of numbers and text. It's not always that you need to show visualization. You can always show numbers and text and show what happened, right? So after the pilot program, 68%. This is also data visualization. Can you guys hear me okay?
Yes, Manjana.
Okay, I was a power fail. I just had to quickly switch to another network. Okay, so this is one way to do this, right? You just get to the point directly and then you say, this is what happened. This was the outcome. 68% was successful compared to 68% of the kids expressed interest into the program compared to 44% in the beginning. So earlier it was 44%, now it is 68%. It gives you the information right up front. There's no more beating around the bush. You get the details. This is one way to tell the story. Another way to tell the story is you can further drill down. You give that as a KPI and then you provide additional details. So for example, one of the additional details you could give is, where did the shift happen? Or rather, which was by each of the categories. So earlier when you ran the survey, they said this many were bored, this many felt not great, this many said, okay, this kind of interested, excited. So this is before and after. The gray is before, the blue is after. Now you get to see before and after what is the change in values, right? Now you see bored and great. Do you see major difference here? In fact, people who were bored are now more bored, right? Do you agree? People who were bored are now more bored. People who felt not great are now feeling even more not great. And it's just likely, I mean, people, it was just validation that this is not for them. But then people who were in the middle, again, this was 40%. That actually, I mean, it was not that many didn't actually feel. Now it is set 14%. So the big jump didn't happen. Most of the jump happened actually in the later segment, right? Where people who were kind of interested are now more interested. And people who were earlier said excited are now even more excited. So this tells you, again, goes back to the management guy. Does he really care about which segment of users did the actual shift happen? So before the program, the majority of the field just felt okay, but after the program, more children were kind of interested and excited. So the shift actually happened here, right? Now, another way to do this is you again look at the way in which numbers and text and visuals are brought together to express, communicate the data, right? So how do you feel about this? So these are the different categories. And you put before and after, and then each of this becomes, so this is the Marimekko chart, right? This tells you before and after with the same scale where the biggest drop happened, right? Before there are these many, before the program, majority of people were just about okay, but after the program, more children. So what you want to see is, what do you want to see more of orange or do you want to see more of blue? Do you want to see, exactly right, so you want to see more of blue. So now you see that visually colorful way, I can see now there's a little bit of blue here, but there's now more of blue here. See the speed in which you're able to make a decision, right? If I see more blue here than this, then I know it's a success, right? Because this maps to kind of interesting. Again, it's a combination of how do you use all of this text and content and colors to communicate. This is a slope graph. Again, visual literacy is very important. Not everybody gets a slope graph. What is a slope graph? Slope graph tells you the change of data before and after, and it uses the slope as a way to indicate was there a drop or was there an increase. Now here, if you see, the 40% actually dropped to 14%. So this is not really good. But then the increments happen actually within this. So the 25% became 30 and 19% became excited. So this tells you that a lot of the people in the OK actually were felt, they're still not convinced. But then the biggest, the contribution actually happened with the people who were excited and kind of excited. So now there are different ways to tell the story, right? So again, this is the explanatory storytelling exercise, where you are trying to, let me go back to the two techniques that we talked about, right? So that you guys get what we are saying. Again, just keep this in mind, it's very important. There are two kinds of data storytellings at a very high level. One is exploratory. In exploratory, you don't know what you're after. You just got the data. When you've just got the data, just like in data science, what we do is we take the data, put visuals on it to see whether visually are you able to see any insights or not. Are you getting enlightened by something that otherwise you would not be able to see, right? That is exploratory storytelling. So exploratory storytelling could be at the end of the exercise. If you're a data analyst or a business analyst, let's say there was a drop in product sales for a particular category. Now you could start with the question: why did the sales for product category ABC drop? You don't know the answer. So you're trying to explore. So you take all the data, you put visuals on it, just like the way we saw on the explain, right? You take the data, you put the visuals on it, you see if there are any visual patterns, you pull the data in, and then you slice and dice and drill to or not. So that is exploratory storytelling. So that when you try to go to your boss again and try to explain that here is why we lost, you're able to tell them in a story fashion. I started with this question, I went here, from then I went to this other place, and then I found an insight here, I dug deeper, I realized that the sales dropped because of a feature that we are no longer supporting, for example. That is one form. The second form of storytelling is narrative. Narrative is you are trying, the insight, you've done the analysis, you've got the insights, and you want to explain the relevant of those insights to a user. You're not starting by exploring, you already know what is happening. An example for narrative is what we just talked about with the science program. You know it was a success, and what you want to do is you want to explain the outcome of that success or the outcome of the program in a narrative fashion. So you take a set of visuals, you combine text, numbers, all the different elements to it, and then you explain what is actually happening to the audience and why some particular insight is important, right? So these are the two very broad ways of storytelling. Let me quickly jump into the question. Would be better to present? Okay, would it have been better to say? So the Likert scale, Rajkumar is saying, would we have changed it to bored to okay, bored to kind of interested, and bored? You could. I mean, those Likert scale is up to you on how you would want to define. Again, because these are second and third level students taking it. Remember, the survey is being taken by second and third level students. So you want to keep the explanation as simple as possible. And then if you're talking about how that ultimately those insights are being presented to the executive, you could do that too. You could take the category from one category to another category and say, here is how it kind of moved from there. If that is what you're saying, you could do that too, what you say. Okay, so that's on the storytelling concept. And I just want to quickly talk about a couple of things on the tools, right? Before we jump into some Q&A. I know we have only 15 minutes. So on the tools, this is the way I classified. There are four major categories of tools for data visualization. If you want to go and build yourself on this, right? So you either have commercial tools, Commercial tools are all the ones that are provided by these big companies who have BI tools and whatever, right? So Tableau, Power BI, Oracle, Google, all these guys. These are used by companies who don't want to build anything. They don't want to have IT power. They just want something out of the box that they can configure and build. And then you have open source freemium. So these are tools which are library based. You don't have to pay for them. They have a free model and then they have a premium model depending on what you're trying to do. And there are certain companies which will go for these open source tools because they have, for example, one of the reasons I've seen is, let's say you have a company with, I don't know, 10,000 users. These commercial BI tools, most of them will go with sometimes the user-based licensing. It will be very difficult to pay for 10,000 user licenses. So instead, what these companies will do is they will set up an IT team, and they will get these guys to take these open source tools and then build visualization. It becomes a lot more cheaper. You can manage and stuff. The second reason is open source tools, some of them actually have a higher performance output and threshold than the commercial BI tools. Some of them can run into gigabytes of memory and all of that stuff, right? In terms of processing. So if you want control on that, you go for open source and premium. R and Python, JavaScript is if you want to embed stuff in your UI, you want to embed a visualization within your existing web application, you can use some other JavaScript. Like D3, for example, is the most common one. AMP charts, high charts, these are all really good tools. And then R and Python libraries. So if you have data scientists, they're working on data science tools and libraries, and they would want to use libraries along with them, right? So that's when they use. Again, which tool do you use what? I just touched upon this, right? So commercial BI tools, if you use for, the users are primarily your executives, business users. They're not going to use JavaScript stuff. They're not going to use open source. They want stuff which is pretty sophisticated, modern looking, a lot of features and all of that. Open source is more towards people who are looking at wanting to implement on their own. They have an IT team. They have the technology, skills and all of that stuff. R and Python, like I said, for data scientists, and JavaScript is more for developers. And again, a lot of different tools are offered. If you want to know which are the ones, you quickly go to the Gartner BI quadrant, and then pick up, look at the different tools. Again, these are a very small set of vendors. All of these guys have their own strengths and weaknesses. Power BI is like I said here, they have excellent breadth and depth. They have a lot of visualizations. Sometimes there will be problems when you're working with large data sets, but then they have a lot of visualizations. Tableau has been an industry leader for a long, long time. Very vibrant community of people, a lot of adoption. Now it's used by Salesforce. And there's Oracle, works well if you have a lot of Oracle tools and Oracle analytics and all of that together. It's picking up a lot of traction in the marketplace. And there are a lot of other vendors. Again, the thing is, you cannot learn every tool. I mean, all the visualization tools more or less have the same way of working. You just pick one, you go from there. If you know one, you'll easily pick up the others. It's like learning Excel and Google Sheets. If you know one, you can learn the other. Open source, freemium, these are the different open source and freemium tools that given, again, screenshots of things. Again, like I said, it's used by people who have IT teams who are comfortable in managing stuff. JavaScript D3, this is an example for a D3 visualization. You can embed this within your existing web application. So let's say you have a application that you built for browser based, and then within that you want to embed a visualization. D3 is the way to go, and D3 is the gold standard for all of this. And JavaScript, there are a ton of libraries. In fact, this is the wiki page. If you go, you'll see a ton of libraries where you can see, again, breakdown by different features and chart types. You can pick up the one that is relevant to you. Not something that you might do, but if your organization is evaluating, they can use this to evaluate which tools to go. So ideally, you want to pick ones which is green all through, right? Like for example, any charts, and charts, all of these ones. R and Python libraries. I'm not going to go into depth here. ggplot, matplotlib, cbon. These are very famous and commonly used tools. There's also this increasing thing of design and data visualization coming together. So you talk about designers who work on CorelDRAW and Adobe and all of that. They also want to do visualizations, but they can't code. They can't use commercials. So there are tools like Microsoft Charticulator, for example. So what these tools will do is they'll help you build visualizations like these, but you don't have to write code. It's all configuration. And then you can import these custom visualizations within Power BI if that is what you're using. So you don't want to use the same old bar charts. You don't want to use the same old, pie charts. You want to create your own custom viz, like for example, like this, there's any of these. Then you can use Charticulator. Again, you don't have to write code. Give it to your designer. He can configure the visualizations, and then you can import that in Power BI. So again, if you don't want bar charts and column charts, you can use these fancy looking charts from this thing called data-driven guides, which is used by Adobe. Likewise with Data Illustrator. All of these three tools that I talked about are tools that are primarily used by designers who don't want to use JavaScript, who don't know BI, who don't know R, Python, none of that stuff, but it's a design-first approach for creating visualizations. So that's what these tools are meant for. They pop up really well and nice. There's a dedicated class of tools for geospatial. So if you are in the business of location mapping, logistics, all of that stuff, and these are the tools to use. There are also large screen data visualization. You go to airports and convention halls and all that. You see those huge, beautiful displays, right? And there are dedicated libraries for those because those have to render. It's not just a video running in the background. It's actually a visualization running in the background. So these are the different packages that are available. Vendors who have these large screen visualizations that you can render on a large screen. And these are the kind of applications that you can have. Command centers, activity centers, exhibition centers. There are dedicated libraries for them. The best part is when they work so nicely on these, they'll also work nicely on the small screens. So pretty good. And earlier there was a question on thought leaders, right? Who are the thought? These are the ones that I follow. For example, that the exercise on the science program survey came from a book that this lady authored, Cole Busbammer Knaflick. She's got a website called Storytelling with Data, extremely popular website, a lot of interesting stuff, very simple, not too complicated. This is Edward Tufte we spoke about. Stephanie Evergreen is another person that I follow. She has again a thought leader in the space, does a lot of teaching. Again, I'll share the deck, but these are so if you want to get started and follow some of these thought leaders and see their philosophy and principles and all of that, these are the people that you should follow. What was a book referred to? Netflix. I didn't quite get that. Like, can you say it again? Netflix. Shivangi, that's a question that we'll probably need a separate one-on-one. It really depends on what the user wants and what you're trying to display, the volume of data, the type of data, all of that stuff. What was the book referred to? Book on data storytelling. Still not getting a question. So she authored a book called. She authored a book called Storytelling with Data, and you can use that for learning more about storytelling. Like, you can reach out to me and we can talk about your question. I'm not sure if I'm following your question. Any book you referred to read on storytelling? Yeah, so that's the one. So she has a couple of books on storytelling. The author is Cole Busbammer Knaflick. You can read her book. All of these guys, in fact, have books, most of them. But you can start with her. It's very simple. Her website is very good. And then you can get into the books with Stephanie Evergreen as well. So Stephanie Evergreen gets into a more research-based thing. She talks about why something works and gets really to the core of the foundations. So you can either pick a book from her, or you can pick a book from her. Albert Cairo has written a couple of books. All of these guys have written different books. But I would start with Cole. We get to Stephanie and then get to the others. Okay. And in terms of trends, before I get into Q&A, so the trend that is happening is you see a lot of this convergence happening, right? So you see, data journalists and BI, and it's becoming into data journalism, where you see all of these different fancy visualizations that is taking this to a whole new level. So it's a combination of journalism, design, and data, and academics, and BI, all this kind of mishmashing together. And then there's a lot of auto stuff that is also happening. So you have these almost all of the tools today will, you just give it data and it'll automatically visualize for you and it'll tell you what insights it is finding. And so it really expedites the need for the person to do stuff. And then there's integration with phones. If you have a phone, you can use a phone camera to scan so this is an actual example of this tool that Oracle has, but even the others have. The Oracle tool is called Synopsis. So you can take you can have the app and then launch the app and then trigger the lens. Then if you have a table that is being displayed either on let's say you're in a conference, you're seeing a table being projected in the projector. You just take the phone and then just scan the table and then it'll automatically render the visualization for the table. So these green lines, I think about the lines for this column, and the blue bars are the bars for this column. So it'll do all of that stuff. You can scan a lot of data elements in all the different places you find, like nutrition, and capture this and loaded stuff and all. There's a lot of AI NLP that is happening. So voice based, right? So there's you don't even have to create stuff. You can ask the system, show me, like it says here, show me revenue and cost by customer and product, and it'll automatically render the visualizations for you. So you don't even have to know what visualization is being used, where the data is coming from, all that. It's ready to consume, good to go in tip of your fingertips. Then in advance, you see a lot of AR stuff coming in, right? So you literally should be able to walk into your schema and then look at your data elements using augmented reality. This is a little, there's stuff already happening in this right now, but again, with digital twins and all that stuff, even with this, the ability to bring in AR, VR into your data spaces and actually experience data, walk through your data repository and islands and see how things are shaping up and all of that stuff. This is also taking stuff to a whole new level. But there's a lot of interesting stuff happening here. This is really taken off like crazy. It's come to the case where if you know Excel, Word, PowerPoint, you're supposed to know now visualization also, because it's the same level as competency, right? Pratul had that problem in that tool, but then it's easy for anybody to create those visualizations yourself. You don't really need a formal training or a paid course to go and learn how to learn visualization. If you know it, just like how you probably didn't pick up an Excel course, course for Excel, you probably don't need a course for any other visualization tool. Yes, that easy and self-service to use, that you should really be adding this to your skill set, be able to produce assets, create dashboards, all of that stuff. Okay. I know we've bit into the Q&A time, but I'm happy to take questions on Q&A. We can have follow-up meetings if required. I'm happy to talk on this. Like I said, I'm a student of this field and love to engage more. Any questions for today? Shivangi, let's talk. Reach out to me and let's talk. Right? I'm happy to share some of my thoughts and talk about how well you could do that. At least I can at least set you in the right direction on how to start with this. But then again, I think the key takeaway, one thing you got to guys have to remember is remember the Iceberg effect that I talked about, right? See, this is reality. Okay. Creation of visualizations and charts and dashboards is very, very easy. It hardly takes any effort. But then the majority of the effort that is required is again on data extraction, like one of you spoke about in terms of technology. But then it's also the ability, do you understand your data? Do you understand how they are related, the cardinality relationships? Do you understand how information is extracted? What measures and calculations can you set up? What questions do you want to ask on the data? And then the tool literacy and then the visual literacy. Am I using the right visual, right form? Is it easy to understand? All of this stuff. This is the real deal. If you get this part, this is walk in the park. Really, really easy for anybody to pick. Okay. So Shivangi, let's talk whenever you have time, and then I can guide you based on what I know. Any other questions, folks? I know it's been a marathon time, and usually we do a lot of hands-on together. Today it was more of me talking, but hopefully this was useful. Again, the objective was to inspire you guys on this field a little bit, get the bug bitten for you to like think about this a little bit more and use this a little bit more. Takes us back to our childhood days, right? Using with colors and shapes and drawings and all of this stuff. So hopefully this will get you guys. Thanks, Kumar. Any other questions, folks? I'll put my email on the Zoom chat. You guys can reach out to me anytime. We can talk. Any reference to the hands-on? Asit, any reference to the hands-on using tool? Like, what do you mean? So Kumaran question is, how do we do mock design as CFO dashboard, find out in which sequence or graph do we do this? Let me answer this. Any recorded video on, I will send you a recorded video. There are a ton of videos on YouTube, Asit. Depending on the tool of choice, if you're using Tableau, using Power BI, using Oracle, any of the tools, there are a lot of videos available that show you from installation onwards, how do you set things and go for that. Let me know if you're not able to find, I can point you in the nice direction. Thanks, Midula. So Kumaran, the question is, how do we do a mock design? So from my experience, it's an iterative exercise. You always start with the CEO, understand what is he going to do with the data. So we talked about Dr. Stephanie Avedrin. One of the storytelling concepts that she talks about, which I try and follow, is it follows a very three-step philosophy, right? At the end of your visualization, you've got to be able to answer the question what, so what, and now what. Means you've rendered something. Okay, what is it? So what means why does it matter? And now what means what should we do? Now got to go back to the CFO, CEO, and look at what is it that they're trying to do, and that should come in what. The so what should be why should they care, and now what should be what should they do. And getting to that agreement is never a one-way philosophy. It's a series of at least 2 or 3 iterations. So you understand what the user wants, what is it they're trying to do, and have 2-3 options and how best they can do it, and then have a sort of very concrete recommendations on what is it that they should do to fix it. And that cycle will be, there's at least 2 or 3 minimum meetings you need to have with those guys to get a sense of what they want and you presenting what they want. And half the time it will be so happy that what they want, you don't have the data for it. And so you will start with the project and say I want to see a particular insight or a particular outcome of this exercise. But then you go back and see like there's no data for it. And then you got to go to the data guys and say, give me that data. They'll give you the data. Then you'll see the grains are different. You'll not be able to join. So all of that problem happens, but then the user requirement is key. Got to understand what is it that they want, and then see what boundaries of data you have that using which you can fulfill, and then try and best to fulfill. And then over that, the project will keep building going forward one by one. That's the best I can tell you at this point. And that's the way it has worked with me as well. It's never a one-way exercise to do this. But the mock-up, you can do it on the tool itself. You don't need to go to a design tool and create mockups. You can actually create it on the tool itself, but then that is only in the visualization. The ultimate story, the insights and all of that stuff, that you have to figure out outside. The visualization tool will just give you a sense of how ultimately things will look like, but what the user wants and what they want to do with it will drive a lot of what the user is trying to do. That is more important. I don't know if I answered your question, but right, but I understand where you're coming from. The sequence also is important on the story. Again, use that 3 steps thing that I talked about, right? The best way to create the sequence is to split the sequence into those 3 steps. The what are you presenting? The next step is so what. Okay, now you presented this, now so what? That's the second set of graphs that explains the so what. And then now that the audience understands why this is important, then next thing we would want to know is now what? Like, what do we do? And that will be a third layer of, and I mean, that will be the topmost layer in your cake. We will have to have a series of graphs that says, here are the insights that I found, which could potentially lead to paths on what is it that we should do to fix the problem that we saw in one. Okay.
That was brilliant. Thank you, Manjuna. That was a very interesting and insightful session. And I think we're already done with the Q&A, and I think you did it brilliantly along the way. It wasn't kept for the end. I think the audience were quite excited enough to even ask the questions as in how you went along with the session.